Let's see if this seems to be working. Yeah. Okay, so it looks to me like Twitch is working. I'm going to test something. Testing. Yeah. Okay, so it looks to me like Twitch is working. I'm going to test something. Okay, Brian, would you do me a favor and just say anything? Looks to me like Twitch is working.
Yeah, I'm here.
I'm going to test something.
On, you
Okay,
want me to type
Brian,
something?
would you do me a favor and just say anything? Like Twitch is working.
Yeah, I'm here.
Yeah, cool, it's working. It's
you
got
want me to
like a 7-second delay or something, but hopefully you're comfortable with being on the stream, Brian. But this way, you can just ask questions. I think that'll be better than like typing in a message and I can see it 7 seconds later.
Yeah, that's perfect.
Cool. So yeah, I'll just give a couple minutes for, I know if nothing else, Anna wanted to join, and I'll tweet out this link. Okay. One moment. How are you doing, Brian?
Good, how are you?
Doing pretty well. A little bit of a headache, but
Okay.
not too bad. And I just took some ibuprofen
Nice.
and have a coffee, so I think
Good. Good.
that'll help. Yeah, I'll give another minute or two and see if AnthroCipher is going to come online. But we can maybe just go
Okay.
and take a look at some of the kind of context for this issue.
Sure.
Brian, have you looked at the PageRankGraph design doc that I posted?
Are we talking about the issue?
Yeah, this one.
I've looked at it, yeah.
Cool. Yeah, so the basic idea, I'm just going to kind of go through this and remind myself what the plan is for this this code we're going to work on. So basically, I think the idea is we have a really nice graph abstraction, which I'm pretty fond of. And I'm actually going to just open this up. Let's make a new branch. Maybe even have some branches for the PageRank graph. Hello, AnthroCipher.
Hello, Decentraland.
Yeah, welcome to the Zoom. Just so you know, this is getting streamed, so just don't say anything you'd be uncomfortable having on the record. And we're just getting started. So yeah, just kind of looking at context. we've got this really nice graph class. It even now has, well, let's rebase. Actually, I'll start on master and just look at the stuff. So we have this really nice graph class. It's even now got some good documentation. And it presents a pretty like consistent and like I think like reasonably intuitive interface for interacting with graphs. You add a node, you remove a node, you check what nodes there are, you maybe like get the neighbors to a node, you find out what edges there are, you iterate over them, you like find individual ones, you add them. And so the main thing that we want to have graphs for in SourceCred is so that we can score them by running a PageRank algorithm. But in the code base as it exists right now, when you actually want to run PageRank, you have to dip into a totally different API layer. And it's this, let's see, core / what's even the name of this? Attribution. And so the way that we do PageRank is we have this graph to Markov chain function. And a Markov chain is basically a data structure that describes how you can transition between different states. Or another way of thinking is how like probability mass transitions across states. And so we kind of think of each of the nodes as being a state, and we transition from state to state based on how the nodes are connected to each other. And we have first a file whose job it basically is to convert a graph into a Markov chain. And so we have like, let's see, a node address Markov chain is a map from each node to which nodes gave it incoming probability. And we create this data structure that has all these connections from the graph. So let's see, we have create connections, we take in a graph, we take in a function that assigns weights to the edges, and we get back this node to connections. And let's see what a node connection is. Okay, so it's a map from the node address to the connections, and let's see what the connection is. And the connection is just basically like what is adjacent. Is it the synthetic loop? Is it an in edge? Is it an out edge? And what's the weight on that adjacency? And so from like a mathematical perspective, this code is fine, and it's even pretty performant. William and I back in the day did some optimization on this to make sure that we could run PageRank pretty quickly. And so when we go to like SourceCred.io/prototype, and we go and analyze cred, it's loading the graph, and then it does the entire PageRank convergence just like that fast for the SourceCred graph. And we can find the other attribution file is actually Markov chain, and here we have all of these like undocumented functions, sparse Markov chain action, which like takes the graph one step closer to convergence by flowing weight across all the nodes. And find stationary distribution, we basically just keep on doing that until either we have exceeded the maximum number of iterations, or we're below the convergence threshold, which means that the graph is very close to perfectly converged. But these APIs are just like confusing. They're not in the same kind of space as what the user is thinking about. You need to like learn a new level of abstractions here. So I think that to kind of make a metaphor to Git, like if you really learn Git, you realize that it's got all of this really complicated stuff going on along the blobs. And like if William were here, he would know the exact commands. Like you can look at like ls-a and ls.git, and you have all of like your objects in this like hash. Here we have sorted by the hash all of the different objects in SourceCred, and we can ls.get just branches. We can see what ls-a maybe. That's interesting. Nothing there. Oh, is that just a file? No, it should be a directory. But in any case, the point is that this is stuff you don't really need to know about in order to use Git, because it's abstracted over by another layer where you can actually just like show the objects directly or interact with branches and commits. So there's plumbing, which is here, and there's porcelain that's one level above it. And so I think we basically right now are in a state where for PageRank and SourceCred we have plumbing, but we have no porcelain. And especially, I think one of the things I would like to do, and I think Brian, maybe you alluded to this in an issue or a comment somewhere, is I'd like to make it easy to build little example toy graphs that just have very simple semantics, and so we can explore exactly like, okay, let's suppose we have exactly this graph, and it's got like an author who like created 3 things, and then one person reacted to one of those things. How does the cred change as a consequence of the reaction? And we could use this to just produce little test cases and like say like, okay, is it possible to like game your cred by just having all of your issues reference each other. Well, maybe if we had a little toy graph generator, we could do that quite easily. But right now, it would just be really cumbersome to write because we don't have good abstractions for it. So that's kind of why I want to make this PageRankGraph to begin with. And I have this issue where I wrote a little design doc in which I kind of explained some of the context, and I went ahead and, let's see, what were my goals in mind? So we want to have a clean API for running PageRank, and it should be clean enough that we'd want to put it in core. Historically speaking, core kind of contains those pieces of soft code that we really like and are super solid on and just think is great. And everything else is stuff that's like a little bit more in flight. It's not clear in the long run whether this is the right distinction, but it kind of is the way it is right now. And this PageRank graph should be good enough that we'd want to put it into core. We need to have a good serialization story. This is one of the other problems right now with PageRank is that we don't have a good way to serialize the results. And the kind of motivating problem that's driving this issue is that right now, this flow where we run PageRank on the graph by pressing a button in the UI is actually the only way to get the scores. We can't run it on the back end because we don't have the right way to serialize the scores and serialize the inputs to the scores. And so that's just weird that we can't make an API to this because it only lives when you push a button in the browser. That's just obviously something we should fix. And so that means we need to have good serialization. We want to have the API be reusing the conceptual vocabulary of graph rather than creating a whole new set of primitives. And okay, that's right. And we want to be able to reuse the PageRank state. So what that means is basically, let's say that we are doing an exploration where we have a graph and then we go and slightly change that graph, or we change the weights. Right now, let's say that I'm on a bigger project, so like JS IPFS, it takes a little bit longer to run PageRank. And if I go and change the weights, then when we run PageRank, we actually rerun it from scratch. We just throw away all the data and retry. But when you think about it, by the time that we've run PageRank to convergence, if we change the weights a little bit, that graph is still the scores are almost correct. They're just off by a little bit. So we should just be able to do a couple more iterations to reconverge it rather than starting from scratch. And so that's why we want to have the ability to recompute PageRank quickly if we've just changed a little bit in the graph rather than restarting it from scratch. So those are kind of the goals for this piece of SourceCred that we're about to build. Any questions?
Each time to the graph instead of having to run PageRank across every.
Sorry, could you say that again?
Yeah, my internet went out for a second. Would that help with you would that help with time-based cred, keeping the distribution so that you didn't have to recalculate it over every time period?
Potentially. I would say at this point it's not sufficiently clear how we're going to do time-based cred to really say. I mean, I think that generally speaking, yes, having this flexibility will probably be helpful, but it's hard to say exactly how because we don't know what time-based cred will look like exactly.
Okay.
But yeah, I think that's a really good intuition. I think that it's pretty likely that the way we get time-based cred might be by first finding convergence on the whole history and then kind of narrowing scope in some way. But yeah, I'll say good question, but also kind of out of scope for this, part of the project. Okay, so I produced this API sketch of the PageRank graph, and maybe we'll talk about it a little bit. We'll talk about the things in it that are a little bit weird, because there are a couple things here. Part of the reason I haven't built this yet is because there are a couple pieces that I'm just is that the right way to do it? So the first things to note, PageRank graph, what are the inputs to the constructor? So this is already something that's a little bit weird. So you construct the PageRank graph by giving it a base graph that is actually already complete. This design calls for PageRank graph to be something once you've kind of finalized your graph and you've put in all of the nodes and edges that you're ever going to put in, then you wrap it in a PageRank graph, and then after that you're allowed to change the weights, but you're not allowed to change the nodes or edges. This isn't a hard requirement. This was just something that made it kind of more convenient to implement. Okay, another thing that's kind of weird. So the way that we handle scores in SourceCred, you might notice that all of these scores for users always sum up to 1,000. And that is just a bit of additional computation that we do on top. Originally, when in a very early version of SourceCred, it just gave the raw distribution. What PageRank produces is a probability distribution. And so that meant that all of the nodes in the graph in total would sum up to 1. And that meant that as a user, you would have pretty typically a score of like 0.0003 or something like that. And it was just not a very good, humans like numbers that are greater than 1, not numbers that are some tiny fraction of none. And so we just renormalized it so you can always just tell, like, okay, 230 cred, that means that David has done about, like, has about 23% of the cred in the project. Just, like, simple, consistent. It's not clear whether the PageRankGraph is the right place to do this. My current design calls for the PageRankGraph to be including the score normalization. And now that I'm, like, trying to describe this, I think that's a bad idea. It's just like logically speaking, I think we should redo that renormalization at some other layer way before we display the scores. But to have the PageRankGraph also know about like whatever strategy you're using for scores, I think is it's just a bad separation of concerns. So let's make a mental note that we're not going to put that in there. Okay, so the synthetic loop weight. You might notice as you're exploring the SourceCred UI that every node has this synthetic loop node that connects them the node to itself. So if I go and find, for example, like some, let's say comments probably have less connections, and I find some relatively unimportant comment, yeah, it also has got this connection back to itself. So the reason for that is that if we have any node that's not connected to anything, then the math for running PageRank doesn't work because you can't like flow any weight out of that node and it doesn't like normalize properly. And so the approach that we took is to give every node this like really insignificant connection back to itself. And that really insignificant connection is the self loop weight. And so I think that right here I have the constructor taking the self loop weight because it's one of the things you need to do for serialization. And similarly, the constructor takes the scores and takes the edge weights because these are things that if you're reloading from disk, you need to have it available for serialization. I think that this is probably a bad interface though. Like I think that if I'm just looking at this as an API consumer, in code, the vast majority of times when I'm creating a PageRank graph, I don't want to have to set these parameters. And so let's just start coding the actual interface that we want. So make a new branch, we'll call it live coding PageRank graph. And let's just start hacking on things a little bit. So we're going to go in touch source / core / optimistic here, we think it's going to go in core PageRank graph.js, and we want to have a test file too. So .test, .js. Okay, so now we have these 2 new files, which is great. How many windows do I have? Probably too many. Okay, so it's going to be a flow file, and we're going to export class PageRankGraph. Let's just kind of go for here. So constructor, and let's say we want to take the graph, and we probably do need to take the synthetic loop weight because I don't think we want. I'm trying to think if we'd ever want you to be able to change the synthetic loop weight after creating the graph. We might allow that, but for now, let's just take it. If we can make it optional and have it default to some tiny value, then people don't have to think about it. The weight we use to connect every node to itself to insert. And okay, so why am I writing the constructor returns the type signature of void? It turns out that so Flow has a number of like pretty gnarly bugs hidden within it, and one of those bugs is that under certain circumstances your constructors will return the any type, and in those cases you can just have these weird type errors like percolating across your code base, and they're really hard to catch. And so after being burned by this once, I realized that if you mark your constructors as returning void, that just prevents that category of bug. And so this is like a weird accommodation I've learned for the fact that our tools are slightly broken, which I don't like. This kind of thing happens all the time in JavaScript, by the way. This is like part of like the experience of being a JavaScript programmer. In my experience, is like learning these weird potholes and how to avoid them. But so that's why I put a void there. Okay. And now we're actually in this, so we can think about what properties is the graph going to have. Okay, so it is going to have scores. Scores is going to be a map from node address t to number. Yeah, that makes sense. The score for each node, always normalized so that it's a valid probability distribution, i.e. score sum to 1. Every score must be in the range 0. So we've got scores. Oh yeah, we have this underlying graph, obviously. And let's just undername all these properties. And we're going to have edge weights. Is that the right name? Yeah. Probably I'll put a better doc string there, maybe before I merge this.
Why are you using underscores?
So the reason I'm using underscores is because I think it's pretty likely that I might want to have a method for, so I tend to prefer to use methods as accessors rather than direct property access. So for example, let's suppose that, we have an API caller and then we do const pg equals new PageRankGraph, my graph, and then they want to get the graph back. They could do pg.graph, const graph equals pg.graph. I prefer not to have people do this on classes. I prefer to have them have an accessor method explicitly. And I guess I like doing this because it makes it just clearer on an API layer that it's only an accessor and that you're not allowed to set it, right? So if I have const graph equals pg.graph no method, then you might think that I can go and say, oh, pg.graph equals my other graph. And that's actually not unintended behavior, and that would break the class potentially. In this case, we could do it as a read-only property. So we could say it's graph, but like a plus, so it's read-only. And then flow would catch an error. And maybe that would be fine, but the style that we've been using in the code base is just to generally prefer to make things accessor methods. And so if I think I might want an accessor method called graph, then I can't name the property graph, otherwise there would be a conflict. And so, and we can see if I'm about to tell the truth by looking at graph itself. Yeah, just generally speaking, we tend to make the properties underscores, and then that just avoids having to think about conflicts there. And so, for example, on graph, there is a nodes method, and there is an edges method, but they don't conflict because we've underscore named the properties. So we have graph, scores, edge weights. We are going to have a synthetic loop weight, which will be a number. Connects every node to itself to avoid isolated nodes. And
can you enumerate why using underscores prevents us from having to think about conflicts?
Yeah, so when I make, if I were not making naming all the properties as underscore, then when I make a graph method here, which let's add a graph method because it'll just be a good thing to have on this class, returns a graph, and return this dot graph. If I wasn't underscore naming things, then at this point I would have had a conflict because I would be trying to return this dot graph, but this dot graph, it's not clear whether I meant the property or this method itself. And so, just by making all of the properties underscore named as a habit, unless I explicitly want to make it available for some reason, I just avoid having to think about those potential conflicts. Does that make sense? Cool. Okay, so constructor. We're going to say this dot under graph equals graph. We're going to say this dot under synthetic loop weight equals nullutil dot or else of synthetic loop weight and default synthetic loop weight, which we need to define. And let's actually start importing some stuff. We want to import the graph and type node address t and type edge address t from .sourcegraph. I think I put the imports up here. Yeah, let's get this stuff for realsies. Whoops. And we want to import star as nullutil from .utils null. So nullutil.orelse, let's just take a look at that. I think it's a cool little util that William wrote. And it's basically got a lot of methods for dealing with the case where you have something that might be null and you want to be able to like abstract over the possibility of having a null. So nullutil.map takes something that's maybe null and a function that takes a t that might be null, and it takes a function that takes a t to a u, and then it gives you a u that might be null. Nullutil.orelse, if the value given is nullable, then it gives you the default value. If it's not null, then it gives you the value you specified. So you might say, so I think a pretty common pattern, an alternative pattern would have been like synthetic loop weight equals synthetic loop weight or default synthetic loop weight. And this would generally work as you expect because null evaluates to false. But the thing is that 0 also evaluates to false. And so using this construction would create a bug where when you put in 0, it would ignore the 0 and use the default value. And so using the null util is generally safer. You don't need to think about the truthiness of like values other than null. You can just use it consistently. And let's do some validation. If this dot synthetic loop weight is less than or equal to 0, then we're going to throw a new error. Synthetic loop weight must be greater than 0. Now we have these maps and we're going to initialize them to empty. This dot Okay, so one thing that's interesting here is right now my comments are lying, right? So I said the scores for each node always normalize, so it's a valid probability distribution. And right now there's actually no normalization here because the values are just null for a lot of nodes in the graph. And so you may remember I talked a little bit a while ago about how it would make sense to sort of require that the underlying graph is frozen and that you're not allowed to modify the graph. And one of the reasons that would make sense is that then we could just go and set the scores to already have like sensible values for every node. Like we could start with a uniform distribution over the nodes. And then this invariant that I'm writing here would be true. The disadvantage is maybe just annoying because maybe you want to be able to like have a PageRank graph and then add some more nodes to it and then do something else. But maybe I'm just thinking what we want to do here. Maybe for now we will start in the restrictive mode and say that you aren't allowed to change the graph at all. And then we can, if we actually need the ability to like modify the graph, and we'll do that. But for now we'll just do the simple thing because I think that's better because we don't have any need to modify the graph for anything we're doing right now. So kind of why make it complicated? So I'm going to do a little bit of a like hack to ensure that that's correct. And this is something that we shouldn't actually merge into the code base. We should make an API for it. But so the graph has this property called modification count. And the modification count keeps track of how many times the graph has been modified. And so we can use that to ensure that we have this property that we're sort of requiring a frozen graph, because we can just check every time we're going to do something, we can just check that the graph's modification count hasn't changed. So let's just do that for now. Graph modification count, which is a number, to do, and maybe I'll even put a stop ship. So this will just fail a test. Stop ship, rather than poking at graphs private properties, expose an API for the modification count. But so now that when we're getting the graph, we can also go and say this dot underscore graph modification count equals graph dot modification count. And let's have a method that's like verify graph not modified. And it'll say if this dot graph dot modification count not equals this dot graph modification count, throw new error, illegal graph modification after creating PagerankGraph. And now we can just have every method call that. And that should ensure that the graph is not getting modified. And what that means is now we can actually go ahead and like responsibly do the thing that we claimed we would do in keeping the scores always as a normalized distribution. Because now when we create the map, we can go and say, okay, this dot underscore graph dot nodes, or rather for const node of but we need to get the length first. I don't think that an iterator will tell you how many elements are in the iterator. That wouldn't really make sense. So let's actually just make it into an array. This is like a little bit like memory inefficient, but it's okay. Okay, so we're going to say const graph nodes equals array.from of this dot graph dot nodes. The reason we need this is because the graph nodes method returns an iterator, not an array. Iterators are generally more performant. It's nice to use an iterator when you can, because lazy evaluation is often better than eager evaluation. But in this case, we need the array so we can get the length. And now we're going to say for const node of graph nodes, this dot scores dot set node and 1 over graph nodes dot length. So this is basically just setting the uniform distribution. I'm just going to write a little comment. And we have this edge weights thing, and I'm actually going to like hold off on setting this up for the moment because I just want to test the code that we have so far. It's a nice form to be just kind of testing as you go, rather than leaving it all to the end. Well, that, yeah, there we go. But so that we can test it, let's add one more method which gives you the scored nodes. So we're going to say, what did I call this here? Did I call it scored nodes or just nodes? No, it was just nodes. So okay, let's try that. So nodes is going to be a method that gives you an iterator of scored node. And it's going to basically for const node of this dot under graph dot nodes. We are going to yield, it's got to have a star because it's an iterator. We're going to yield node and score. And const score equals this dot scores dot get node. Now this is going to create a subtle type error, and then we'll fix it. Export type scored node equals node address t, score is a number. Okay, and so now we have export const. I think we have everything we need to start writing a little bit of testing. But let's first see what our flow errors are. Okay, can't resolve name edge. Okay, that's because I forgot to import it. Can't resolve name edge weight. Oh, because I need to import it from there. Okay. Okay, so there's a little distinction here. We could write import type edge weight from /attribution graph, or we could import type so from a typing perspective, importing type inside of the brackets or importing type outside of the brackets is exactly the same. The difference is that in this form, where we're saying we're only importing types, the compiler knows that it can just elide that file because it's only relevant for typing and not actually for any like actual code. So when you are importing only types, it's nice to do that. So I'll use that. And then so here there's a funny construction. We're both importing and exporting something. So we are importing the type edge weight from this file, and then we're like exporting it back out. And that way somebody who's using PagerankGraph and wants an edge weight doesn't need to go and poke into that random file. They can just get it from here. So that's just like a little convenience thing for callers to this function. Okay, now I said there'd be an interesting type error, and here it is. So we claim that we're going to be yielding an iterator of scored nodes, and that scored nodes always have score as a number. And the thing is that where we get the score, we get it from a map, and we know that there's definitely going to be an entry in the map there because we configured it so that it had, why do we know it? We know it because we need to put this call here that will verify the graph is not modified. And so since the graph was not modified, and when we constructed the class, we got all of the nodes, we know that this is going to work. And yet, the compiler doesn't know that, because the type signature when we're getting something from a map is that you never know whether you're going to get something or you're going to get a null. So Flow is pretty sensibly warning us here, like, hey, you have not proven to me that this score is never going to be null. It could be a number. And I mentioned how null util was really convenient, and it has this method called get. It has this method? Yeah, there we go, get. And get basically is like, try to get this value. If the value is null, then throw an error. And that turns out to be, turns out to be exactly what we want here. So we're going to say score equals null util.get of this. And now we've basically said to Flow, hey, if this isn't, if this is null, then we're just going to throw an error. So you never have to worry about it from a typing perspective. And so now we have no Flow errors, which is nice. And now the next thing we wanted to do is write some tests. So let's go to PageRankGraph test. I misspelled that. And it's a Flow file. If we forgot to write Flow here, then we just would not get any type checking, which would suck. But fortunately, our tests would catch that. And we're going to import some stuff. Let's see, we're definitely going to need to import graph from /graph. And we're definitely going to import PageRankGraph from /PageRankGraph. And I'm not sure what else we'll need, so we'll grab it as we need it. Describe. So when we start off tests, we always have the file have a describe block that describes the path to that file. And the reason for that is that when you're looking at test errors, like by default, the test runner doesn't always tell you which file the test came from, which is kind of annoying. And so we have just chosen to fix this by always starting the test with the name of the file. And this is another thing which our other tests actually catch. So if you were to name it in some other way, or if you were to move the file around more likely and then forget to rename it, the test will fail. I just love having tests that catch all of the weird stuff that can go wrong. I'm also going to go and just really quickly go to on my other monitor. I just realized that I have not been looking at the chat for the Twitch, and I want to see if anyone. Nope, nobody has sent any messages, so that's fine. Just want to make sure that I would not miss it if they had. Okay, so what do we want to test now? Let's close this window for now. Just get some more space, and let's actually just get it side by side. So we've got this graph modification stuff going on. So let's test that. Describe errors on if the underlying graph is modified, and we'll have it when retrieving the graph. It's a little bit pedantic, but we'll do it. So we'll say const PRG equals new PageRankGraph. Also const G equals new graph. PRG is a new PageRankGraph of G. So now we'll test that, const G.add node, node address dot from parts of foo. I don't know. Actually, let's just make a couple like node names so I don't need to write that all over the place. Like const foo node equals node address dot from parts foo. So a little note. So in test code, we really like to keep good isolation between tests, and we want to avoid shared state. And what that means is often, like, let's suppose that I had an object, const foo object, that we were going to be sharing across tests. We would not declare the shared object for all the tests up here like this. What we would do is we'd have it be a function that returns the object in question, like that. However, for a node address under the hood is just a string. So node addresses are immutable. And so there's no worry that we'll accidentally mutate this node address in the test, because that's just impossible, which is why I'm not making a function. I'm just directly saving the node address. And now I can clearly see that we're going to need the node address module. And I think it's safe to say we'll need the edge address module too, so let's just grab those. Okay, so now we're just adding this foo node to the graph, and now expect prg.graph to throw error a legal graph modification. There you go. Whoops. Can y'all still read the text, or is that too small now? Cool. Okay, and so let's actually reframe the way we're doing these tests. Let's do when adding node to the graph, and let's also test if we're adding an edge to the graph, and I think that'll be fine. And so we're expecting, actually here, let's do this. Const graph methods equals, because what I'm thinking is, I want to test it for a bunch of different methods. I want to test that it's true for graph. I want to test that it's true for calling nodes. Maybe we'll do that for now with the two methods, and if it becomes a really long list, then we'll abstract over it rather than retyping it all the time. And then let's test it for when adding edge to the graph. And so now let's add the foo node already, and then do g.add edge of I'll just make this shared foo edge. There's the magic of having Prettier integrated in the editor. I just save and it formats it properly for me. Cannot use node address T as a type. Something went wrong here. Oh, I see. I was missing a paren. Might be. That'll probably still not work. Right, because now there's still an extra paren there. Oh, but now there's an extra semicolon. Okay, that seems fine. And so notice here, since edges are objects, I'm not creating a single shared edge. I'm creating a function that creates the edge. But so now we can just add this foo edge. And so this just verifies that these methods are working for checking for legal graph modification, and let's see if that actually works. Just want to run the tests for PageRankGraph. Okay, unexpected token. So I just have a syntax error. That's good to know. Let's actually do --watch, so it'll just update us when. Let's actually just first use flow to check that error. Okay, so in line 9, we have an unexpected token. Oh, you know what? Yeah, we needed a, okay, so we needed a paren here. And the reason we needed a paren here is because this syntax here, where we're like just defining a function with fat arrow syntax, it was ambiguous. It thought that these brackets, I intended them as being the like defining a new object, but it looked like it was opening a code scope for that function. And so by putting a paren around, it makes it clear that I'm not like creating a new block that contains the body of this function. I am in fact just defining a like literal object that gets returned by this function. So, slight nuance there. Okay, so now this is new. This is interesting. Aha, I see exactly what's happening. Okay. So this is a subtle bug. So this nodes method is an iterator. And so when this gets called, none of this code actually executes at the moment that you call this function. Because when you call this function, it just creates the iterator for you and returns the iterator. And so when I've called prg.nodes, all I've done is create an iterator. And if I were to actually try to get any values from that iterator, then it would throw the error. But that's not what I want. I actually just want this error to be thrown as soon as you call the function, because that's just a cleaner interface. I don't want errors like unexpectedly showing up somewhere else when I could have thrown them sooner. So to do that, what we need to do is we need to wrap this method. I've actually done the same thing here. So if you look at like the nodes method here, there's this nodes method, and it creates a result, is this.nodes iterator of some stuff, and then it returns that result. And the reason here is that this allows us to do like invariant checking at the function level. So we're just going to do the exact same thing. Feel free to ask questions if this is unclear, because I know this is like a subtle point that depends on understanding iterators. I'm happy to explain in more depth if you want. But we're going to say nodes iterator. We're basically, let's just go and take this method and rename it nodes iterator.
If you want to mention more about invariant checking, actually.
Sure.
I see it a lot, and I'm not sure if it's something, if it's, it looks like it could be expensive in certain places, and I was just wondering if it's something that you do in development and not in production or not, or.
That is a great question. One second, let me just finish writing the body of this function so I don't forget my context, and I'll answer that question. Okay, so this should just work now. Invariant checking. Yes, let's get some more space. Okay, so as just for context, as you may have noticed, the invariant checking, we basically, this graph is written to like, if not spaceship level of robustness, at least like super core part of the project level of robustness. And part of the way we get that robustness is by having this complicated invariant checker. And the invariant checker basically just like validates the integrity of the graph. It checks that for every edge, both the source and destination are in the graph. It checks that the internal data structures are correct, that kind of stuff. Brian, you make a very good point that it could be expensive. And that is why actually, yes, our maybe check invariance method here, if the node environment is test, then we check the invariance, and otherwise we don't. So the invariant checker runs for all test code and doesn't run at all in production.
Okay.
Brian, what tips you off of that might be expensive?
It looks like you're looping through everything, like every node in the graph. This is another question I had. I just don't know data structures and algorithms well enough, but like you're looping through every node every time you check. And I was wondering, because there's a lot of cases where, like in the front end, you'd want to loop through the nodes to filter out for the type you're looking at or whatever. how expensive that is, and is it more expensive to loop over something once or two or more times versus looping over it once and putting all your logic into one loop? If that makes sense as a question.
Yep. Those are great questions. Let's go and do a little aside to talk about asymptotic runtime and complexity of algorithms. Okay, so we're going to make another buffer. So let's take a look at some ways that things could be cheap or expensive.
There's like a part in Cracking the Coding interview where she says it's not more expensive to loop over something twice than to shove all the logic into one loop. And I've never, I was wondering what you thought about that.
So it actually depends on what you mean by expensive. Okay, so let's suppose that we have a const array of numbers equals 0, 1, 2, 3. No, it's not going to be so nice. It's going to be like 53, 997, 63, negative 12. It's just got some array of numbers. And let's say that to start, we want to find, we answer the question: is the number 1337 present in this array? Let's set let's w/temp/example.js. Just trying to get syntax highlighting on. Okay. So if we want to answer this question, probably the simplest thing to do is say, function check for 1337 is for const x of array of number. If x equals 1337, return true, and otherwise return false. So we can see pretty clearly this function is going to iterate over every number in the array exactly once. And so computer scientists have developed a shorthand. Let's actually come up with one other example. So let's say we have another question.
It's a decent example to think about the cred, because we have this, we're working on this issue where we were going to just add up all the cred and then get the average and then do it for each node as well, each node type as well. So I was, in the context of that, wondering if we should add up all the cred for all the nodes. I'm sorry, for each node type, should we get the average cred first or do it on the fly when the user changes their selection, basically, if that makes sense?
Yep. So that's a question of whether you cache and pre-compute or do things on the fly. It's another good question. I do want to go. There's a point I want to make here, so I'm going to do it first. But feel free to hold on to that, and we'll come back to it. Because there's actually a lot of different pieces at play here. There's how performance works for algorithms from a theoretical standpoint, and then there's how performance works for JavaScript web applications in practice, and those actually wind up being related but also quite different. So let's say we have another question. We want to say, do any two numbers in the array sum to 1337? So we have now function check sum 1337 array, and, for const x of array, const y of array, if x plus y equals 1337, return true, otherwise return false. So these algorithms have very different performance characteristics, and we can see that very quickly by using what's called big O notation. Are either of you familiar with big O notation, also known as asymptotic complexity? So we see O of n is a characteristic instance. Okay, so I'm seeing. Great. So in that case, we can, I'll just kind of go through it very briefly. It's basically, as you scale the size of the input, how does the amount of computation increase in the worst case? And I say in the worst case because in the best case, it could be, the best case is that the array consists of 1337 and 0 as early entries, and then this method resolves like immediately, and this method resolves immediately. So the best case is what would be called O of 1, or that wouldn't be O, that'd be some other character for best case. But in the best case, it resolves immediately. But in the worst case, you have to go through the entire array to check. So this is O of n, and this is O of n squared, which means that they're both polynomial in polynomial in the size of the array. I'm just going to go through a couple like common examples, like finding whether something is in array O of n, finding whether thing is in a sorted array O of log of n. And log of n is way better than O of n. This is why if you have sorted arrays, you can find things super quickly. And we take advantage of this in SourceCred in a few places. Finding sorting an array O of n times log of n. So it's more expensive than just like going through the array once, which makes sense because you need to go through the whole array and then like reorder it. In general, like algorithms up to like just intuitively, like O of n, great. If you have an O of n algorithm, you're in really good shape. If something is O of like n squared, it's like starting to get a little bit more sketchy, but depending on your application, that might work. Once you're having like higher coefficients than n squared, that's when I just intuitively expect the algorithm to start to get really slow, although of course it depends on the size of the data. So this question of like, is it faster or slower to iterate through an array once or twice? So there's a trivial sense in which let's consider like let's say that we want to check. We have function check for 1337 or 99. This is just silly, but let's say we really want to know whether the array has 1337 or 99. And let's say we check for number, array number, and then if x equals number. So if we want to check whether something has, check for two numbers, num a, num b, hypothetically, we could just go and say, okay, return check for number num a, or check for number num b. So this function iterates over the whole array twice. In contrast, function check for two numbers faster, num a, num b, does for const x of array, if x equals num a or x equals num b, then return true, otherwise return false. So there is one sense in which, yes, check for two numbers faster is actually faster because you don't have to pay for looping over the array twice, you only pay for looping over the array once. There's another sense in which it isn't faster because if what you care about is asymptotic complexity, this is O of n, and this is also O of n. So the way that we compute asymptotic complexity, we throw away all the coefficients, so we don't care whether it's 2 times n, 5 times n, 55 times n, it's all O of n. This is like, again, more of like a mathematical and theoretical metric. And so if what you care about is asymptotic complexity, then you don't care if you loop over the array once or twice, so long as it's a constant number of loops. And in cracking the coding interview for like whiteboard coding problems, you're usually being asked about asymptotic complexity because it's easy to do on a whiteboard, and like real performance analysis, you have to have like a performance analysis tool. Does that answer your question about why they're saying?
Yeah, that's exactly what I was wondering. That's a really good answer. Because I will take that, go ahead. That's good. That's a really good real life answer.
Now, there's another question you asked, which is you're talking about this in the context of building a UI. And so funny thing about building UIs, and I'm not sure, this is an intuition that I developed before working on, let's actually just do a little bit of like performance measuring here just as we're going. So a funny thing about working with UIs is that evaluating JavaScript is ridiculously fast. V8, the JavaScript engine in Chrome, is very well optimized, and it's just like a marvelously performant beast. On the other hand, manipulating the document object model, is comparatively speaking really slow. React is very clever. React is good performance. What I'm about to say may not be as true for React because I haven't yet done that much performance debugging in React, so my intuition isn't as well primed. But what I expect is that if I have any kind of like reasonably fast JavaScript loop in an asymptotic sense, like if I have an O of n algorithm, and then I'm driving the results from that O of n algorithm to like do O of n like modifications to the DOM, then changing the DOM is going to massively dominate the cost of doing the JavaScript execution. And so, for example, like here, like if I have the choice, if I'm going to go and be displaying one row for every user, and I could do it most conveniently by doing like 5 loops, like let's say it's like 5 loops, one for the usernames, one for the cred, blah, blah, blah. Or I could do it in one loop, but it would make my code a little bit more complicated. I would just not care about doing 5 loops because doing loops over data in memory is so fucking fast. And in contrast, actually putting that data on the screen is quite slow. So that's why I just wouldn't really worry about it. But again, really, the right way to do performance analysis is by measuring. So here we just went and opened some stuff. Let's just do some expansions. We've got a profile, and let's just see what this profile says. Okay, where did we can close that? Okay, so it looks like right now we've got, that's interesting. So most of the time it's idle, which makes sense. In fact, I'm going to just try to do I'm going to do a little bit of a tighter, I'm going to record and then immediately expand and then stop recording. Record, expand, stop recording. Let's just see what that, didn't stop recording when I hoped. So it looks like right now we've got most of our time was actually in scripting. So something was slow in JavaScript land. And then rendering and painting were like a fraction of that. So let's, oh yeah, that's right, we can zoom in here. So let's just zoom in on whatever happened here. Okay, so I clicked something, and the handler was actually pretty slow. It's in red, the 74 milliseconds is in red because you really want, if you want 60 frames per second, then you need things to occur, you need everything that you do in response to a UI change to happen within like 16 milliseconds. And so like this is definitely not moving at 60 frames per second. Fortunately, like when you're clicking a button and having a single change, that doesn't need to happen at 60 frames per second. It's not really like observable. And let's try and figure out why it was relatively slow. So first of all, we got a garbage collection, and that took 30 milliseconds. So that is just a big and like kind of unlucky, maybe performance hit, but it's just that we're probably doing too much like memory churn. But let's see if we can actually go and look at the performance analysis. What was slow? Okay, so yeah, as we said, most of our time was in this garbage collection. Let's organize by total time. Okay, so that makes sense. So unfortunately, because we're looking at the production site, this is bad for debugging. Let's do it locally instead. So I'm just going to go and do yarn start, so we'll have a local instance, and then we'll actually be able to read the code because it won't have been minified. So now we go to localhost, and hopefully it's waiting to finish. I'm going to just send this screen off into the nether, so I don't need to worry about it. Okay, so let's go and load SourceCred. You'll notice now, oh wait, no, that's interesting. Brian, did we not merge yet your number of nodes in the graph change? I guess not.
No, that's actually a little bit of a ways off. That's kind of going to be a little bit of work.
Okay.
Yeah.
I look forward to having it because it is actually a really nice metric to have.
It's going to be a good one.
But okay, so now let's go and do the performance analysis we were interested in again. So we will collapse that. We'll record, open up, and recording. And let's zoom in on one of these clicks again. What's interesting, there are these 2 humps. Because I didn't... What? Oh, let's look at that. Okay, so it looks like there was this one hump of like compute, and then nothing happened, and then there was this other hump of compute, and then at the end of that is when the UI actually changed. So what was happening here? Let's try and figure it out. Recurring handler. Function call. Content script. What is this? Okay, I have no idea what that is. I'm gonna just ignore it for now. In interest of actually like have a message. Just want to check. Ha. Looks like William is following along because he sent me a message. Might want to change your local Webpack config to use prod versions for more accurate comparisons. I appreciate the suggestion, William. For this purposes, I'm probably just going to, I mean, I'm not even sure. Like, let's see, I just wanted to, well, really what I wanted to do is just give an example of JavaScript performance analysis. Okay, so here we have something going on that we can explore. And so now you can actually see we've got like methods that are more legible. By the way, William, you're welcome to join the Zoom call if you want to have Villo speak, but I'm sure you knew that. Okay, so this is a good example of the kind of thing you were asking about, Brian, which is doing a bunch of compute in response to user interaction. So do we want to look at this bottom up or via the call tree? Let's try the call tree. I can never decide which of these I like better. I think maybe it just kind of depends. So first, this is a classic in JavaScript. You know, we've got some framework, in this case React. It's doing stuff for us, and we pay for it by having an incredibly, oh, hello, William. We pay for it by having an incredibly deep call tree that's just got all of this React stuff going on. And so what this does give us a hint, you know, I was talking about how interacting with a DOM is expensive. And so of our like 147 milliseconds, by the time we get down to like code that we wrote, we're down to 70 milliseconds. So the other 70 milliseconds, like just half of the performance off the top, was React doing its thing. And React doing its thing is like heuristically proportionate to updating the DOM. So like half, let's call it like half of the performance here was the DOM update, and half of the performance was the logic that we were actually in control of. So this aggregate flat, when I click on someone here, we've got all of these like maybe like 2,000 edges going out, you know, because I've got an edge to 465 pull requests, I've got 800 edges to comments, I've got 800 edges to pull request reviews, so let's call it like 2,000 edges. And as soon as we click this button, we iterate over every one of those edges, and we sum across all those edges to get the total amount of cred that flowed through that group of edges. And so that's why we have these like aggregate figures here. This 59.73 came from summing over all of those 500 pull requests. And so that's a little bit slow. You know, it took 700 milliseconds to do it. We can go and like dive in, and we can start to like see like, okay, why was it actually slow? It was actually slow because we're creating a map that has, I guess we're creating a map from each type of edge to all of the edges of that type, and updating the map is kind of slow. And that's where 1/3 of the performance. So almost certainly, if we cared right now to go on a little performance debugging adventure, we probably could optimize this. 1 second, let me see why my thing is pinging. I think it's probably just an unrelated server, so I'm going to just mute that for now. Yeah, so if we were on a performance optimization adventure, which maybe we'll just schedule a performance optimization adventure because those are kind of fun, then we could probably find a way to make this more efficient, because I don't think that this has really been like finely tuned yet. But for now, I think it's suffice to say that like, yeah, summing over everything in a type is potentially slow. To your question, Brian, in this case, it doesn't make sense to pre-compute it, because there are so many nodes, and every node has its own aggregation, and of those so many nodes, only a small fraction of them will ever be actually clicked on. If we really needed to like do performance optimization, maybe we could have some heuristic, like saying, okay, for all of the user nodes, we know that people like clicking on users, and users have lots of connections. So we'll pre-compute the aggregation for every user, but not for anything else. But as it is, the UI is still pretty snappy. Like, as a user, I can't really tell that it took 70 milliseconds to do that computation. And so it's not a huge deal. Yep.
Let me just. I'm just thinking about this though, because we need. I'm thinking about this issue now because we need to compute all the cred over all of the nodes anyway, and so we're gonna need. I mean, we're gonna have to do that manually. We're gonna have to look at every single node to compute, because we're gonna have two panes, right? And one's gonna be total cred, and then one's gonna be node type specific. And so in the total cred pane, we're gonna have to look at every node. So, would you not want to just keep track as you're looking at the node of what type it is also, and just do one more computation?
So I'm going to just pull back up that issue so I can have, we can just like refresh the context.
You drew something on the marker board. Yeah.
Okay, is it this one? No, that's a different one.
Yes, that is no, you're right. Yeah.
No, this is just a UI thing. This is where we were talking about putting the like highlight, so you can cross-reference. No, it's a different one.
Oh, it's pretty far down because it's a good first issue. Yeah.
Can I just search like that, do you think? It's this one, right? Add node and
Yeah,
attributes.
that's it. Yeah.
So yeah, I drew this little thing here that was showing like for all nodes what is the total, and for like user nodes in particular what's the total. And so I think that just doing these as two separate things is fine. First of all, because when you iterate over all nodes, that just happens once when you set the thing up, and then it never changes unless you change the graph. And then when you click on a user type, will it be too bad to iterate over every node? So I think that we already do that, right? When I click on filter to like issue, it goes and it then iterates over every issue node and sorts them by cred, and then only renders the top 100, but it actually did iterate over every issue. And that looks to me to be really fast. Let's go and like record and switch to pull request. I don't know. Let's see, how much did that take? So, did it take, what's this? Does that take a long time? It's almost all, a little bit, or no, maybe it was here. I'm going to try this again. Filter, issues. So it should be like in the middle of this chart. Yeah, I'm a little bit confused by what is this yellow bar over here? And is it that my CPU is just getting pegged for some unrelated reason? But I think this was when I opened it. So the bottom line is it seems to be really fast doing this filter. I would say in general, like, the more you want to share computation across different parts of the UI, the more complex things become, because you need to do this like state management where your state is getting shared across components. And so it's a good idea to do that only when you demonstrably need to. I think that in this case, it's going to be much easier to write these components in the way that's like a little bit less performance efficient and just like does this computation fresh for every little pane. And I think it will probably be fine. I don't think it will wind up being a performance bottleneck. And so I would say try to write it in the way that is easiest to write. And then if you do that and then it actually is a performance problem, then kind of iterate from there on it.
Let me ask you another question.
Sure.
Should we, if we're going to, you said we're already filtering, we're already looking at every node when we render this list at the bottom. And I'm thinking that this is going to be a different component at the top, the part where we list the average. Should we move that filter function up to, it's kind of the same question. It's going to serve to iterate once over all the nodes when we filter them. It's kind of the same question, but since they're like going to be connected components.
Right. That's another
or should we
interesting question. Let's take a look real quick on how does like PageRank table. Where does the filter actually? Okay, it's the node filter gets passed down into the PageRank table. Excuse me. Yeah, I think that this is something where I would say for now, just leave it as it is and have another component that like
Okay.
redoes the work. And
Okay.
like again, it'll be less efficient, but I think it will probably be fine.
Okay.
Because going and changing the interfaces so that it passes like an additional thing, and then you need to update all the tests to like respect the new interface. Like, it's not that hard, but it's the kind of work that I wouldn't do unless it was clear that there was a benefit to doing so.
Okay.
If William, if you disagree, I'm happy to hear your thoughts.
Well, just to make sure I understand, the work that happens when you change the issue filter by node type from issue to bot or whatever is not doing any aggregation work, right? It's just like for each issue, it's looking up a pre-computed value in the map and it's projecting that number out, and then it's sorting a list of like 100 numbers. So that's like extremely fast.
I mean, I think it's sorting a much larger list because it only displays 100, but it has to sort all of them. So
Yeah,
they're
sorry, I meant that there
potentially
aren't that many issues. Like even if you're sorting 30,000 issues, TensorFlow has like 25,000 issues as of recently. 25,000 is a tiny number of numbers to sort.
Right.
So yeah, I wouldn't worry about it at all.
Yeah, although what Brian is talking about is, it's summing over them instead of sorting them, but summing is actually faster than sorting because it's O of n versus
Yeah.
n log n.
Yeah.
So yeah, it sounds
Cool.
like we're in agreement that just redoing the computation is fine.
Yeah.
Awesome. Cool.
And I think this gets back to the thing where, like, my guess would be that rendering 100 issues is many times slower than sorting 25,000 issues.
I see. Yeah.
And so it doesn't really matter that much if we redo the computation, especially if it lets our code be simpler. This is one of the nice things, as we have more compute, we get to be more and more like lazy and wasteful with our compute, but that allows us to be more and more convenient with our code. William made some quotation marks.
Quotation marks around nice, but yeah.
Yeah. Cool.
That was a really interesting dive because I would have done that the exact opposite way. I would have tried to optimize everything. That's really interesting to know.
Yeah, I guess it's a Knuth quote. The root of all evil is premature optimization.
Mm.
Yeah, I mean, to be fair, Knuth takes this a bit too far. Like, Knuth also, if you look at what Knuth does, you get a very extreme point of view here. Knuth does not use libraries at all. He writes, like, all his code, the entire stack from scratch. And he writes beautiful code. I've mentioned to Dandelion recently, the last time a bug in Tech was found was 1997. But it took him, like, 10 years to write this system, and, like, another 10 years for it to, like, be useful. So there's a balance. But I do think that like optimizing prematurely is not something that we want to do here.
Cool. So if no one objects, I'm going to close out the performance analysis sidebar and move over back to PageRankGraph. Now, where were we? That's right. We are testing PageRankGraph. So let's see what is going on. Okay, that's right. So we had this nodes iterator thing. We basically needed a wrapper so that we could verify graph not modified when returning the iterator rather than inside of the iterator itself. And our tests are now passing. So that's great. And let's go to graph test. And we also wanted to have some tests. We claim that we're always returning scores. The scores for the nodes are always a valid probability distribution. So let's, do describe scores, and let's make a describe block for scores are a probability distribution. This is a little bit in contrast to the way that I often do testing. I often do the testing like more based on individual methods, but here, since we have like properties of the whole graph, I think we're going to try this. And okay, here's an interesting point actually. I cannot maintain the invariant that I wanted to maintain because an empty graph has no nodes, and you cannot, citation needed, maybe William will chime in, you can't have a probability distribution over no nodes because it can't sum to 1.
Probability distributions over empty sets are kind of like weird. Usually when you have an empty object, there's some like unique, nice semantics for it, but I haven't found a good one for empty distributions. So I don't like, whatever you want to do in this case, I think is fine. Raising an error, showing an empty list, it's up to you.
Cool. So I think we'll just return an empty list because it's clear that for the method that we're actually calling, which is nodes, it's clear that the right semantics are returning just empty thing. But yeah, we'll just have to, maybe I'll just update the comment. Assuming there is at least one node, then scores will be a valid probability distribution, i.e. every score is in the range 0 to 1, and the scores sum to 1. When the graph is freshly constructed. So here we could just do function validate probability distribution on PG, PageRankGraph, and it'll say, like, let's see, const total equals 0, let total equals 0 for const score of pg.nodes, total plus equals score, let has any nodes equals false, has any nodes equals true. Now if has any nodes, expect, it's probably like an expect to be close to method in jest. And let's look for it. So, you know, in principle we'd want to check that it's exactly 1, but because floating point errors are a thing, that wouldn't actually work. Close to, yeah, expect. Interesting. 2 digits. Yeah, sure. I guess that's a fine default. Total dot to be close to 1. Let's do more digits. Let's say 5 digits. Else expect total dot to be 0. Should I update the test block? No, maybe I'll have an init block for the special case. This is like a little bit funky. I think it's fine. Empty distribution. Empty distribution when graph is empty. Oh, and here we should just use our test graph. So let me just copy the invocation from graph. No graph test. Yeah, so we have this quote-unquote advanced graph in graph test util. Graph test util. The advanced graph, I think we made this one like a link. Oh no, we used to have this be a Legend of Zelda based graph, but now it is just a graph with a couple descriptive names. But basically, this means we no longer, this graph has got all kinds of nice weird features. It's got an isolated node, it's got a loop node, it's got some nodes that get added and removed depending on like its history. And so it just makes it easy to like have a graph to stress test things. It's got weird properties. And so we'll have G equals advanced graph. Is that the invocation? Let me see. Advanced graph dot graph1. I think that's it. PG equals new PageRankGraph of G. Validate probability distribution on PG. Okay, let's see if that passes, or if I get a flow error. Okay, no. And this needs to be a function invocation as well. And oh, cool. Okay, great. Our tests are passing. Great. So we're already at a decent spot. We've got a couple things working. Let's go and just commit this so that in case I go and do a bunch of weird things later, we won't lose our work. Initial scaffold for PageRankGraph has constructor, validate graph not modified, and validate scores are population on construction. Okay. So, I feel like it's maybe a good moment to check in with the audience. How are y'all doing in terms of desire to keep watching coding? We've been going for about an hour and a half now.
Could go for a little longer, but probably close to saturation.
Cool. And Brian, for you?
I'm good as long as you're good.
Cool.
Yeah.
All right, I'm going to take like a 2-minute break. I'm going to use
Cool.
the bathroom, stretch my neck,
Okay.
and then I will
Nice.
return. Okay, I'm back, but I'll wait a moment and see if, hold off for Anna to reappear. So, random thought while I'm just hanging out here. I've been thinking about changing my GitHub handle for like the 4th time. And I was thinking of changing it to Dandelion W, which I've started using on a different server. And actually, like, Decentraland is cool and all, but I kind of wish I could just stick to Dandelion. And like, obviously, Dandelion on GitHub is already taken, which is why I went with Decentraland. I think I'm getting like a shakes my head kind of thing from William.
I mean, it's your call. It's just, I don't know. You change your username a lot, dude.
I know. I change it right now. I feel like I've been changing it like once every 6 months for the past few years.
Yeah.
Do all the links still work if you change it?
Sometimes. It depends on the
I
link.
think on our app, I think on GitHawk actually that would break something. the
Yeah.
GitHub manager that was talking about the iOS app.
Hmm.
We have a lot of trouble with links that don't that don't aren't updated anyway.
Yeah. Mutability is a problem, just in general. All right. Well, I won't do it today. In any case, I think we can go back to coding on the PageRank graph. Okay, so what should we do next? I mean, obviously at some point we need to actually do PageRank. But before we do PageRank, I think that we should think about the semantics for edge weights. So just to refresh context a little bit, when we run PageRank, we give every edge a weight. And the only way this happens in the UI right now is that you can set a constant weight on an edge, or you can set a constant weights on nodes and edges, and the edge weight is derived from the weight on the relevant nodes and the weight on the relevant edge. And we need to store the edge weights in some way that can be serialized and deserialized, because that was one of our key goals for this module. And for a user, it's kind of convenient to provide an edge evaluator, which we've defined here as a function that takes an edge and gives you an edge weight. But we also will need to have some interface where you can just manually specify them. And we maybe want to have the graph initialized with edge weights, either because you initially give it an edge evaluator, or more likely because it just defaults to giving every edge a weight of 1, 1. So there's actually kind of a lot of options here. Seeing as William is here, I wonder, William, do you have any thoughts on how this should work?
Nope, not really at this time. I'm still paging in context.
Cool. So I think what I'm going to do for now is I'm going to propose the following semantics. If the edge weights, so the edge weight for any edge defaults to 1, 1 if it isn't set. If you provide an edge evaluator, then you can provide an edge evaluator, and that will go and assign weights to everything, and you can provide an explicit map of edge weights, of edge addresses to edge weights, and it will go and just apply them for you.
So if you provide an explicit map, that could also be implemented as an edge evaluator. So I would vote to remove the functionality that also accepts an explicit map, and maybe provide a separate function that takes an explicit map and gives you an edge evaluator.
That's right. Yeah. Touche. Okay. And I think, though, that I will go and say that rather than requiring an edge evaluator in the constructor, it's just like a mutation that you can freely apply to the graph. Just because it makes the interface a little bit simpler, and it's conceivable that sometimes you want to run PageRank on a graph and you actually just want to use default weights for everything. So that would be something like apply.
So let me
Go ahead.
ask, if you don't mind. Is it again, the default case is a special case of having an edge evaluator, and you could have a default edge evaluator that gives 1, 1, and in fact it's very easy to implement with a lambda. So I think it makes the API, I'm not saying it's wrong, but it makes the API more complicated to have this mutable state and to have this optional behavior where it's not obvious that you can pass this, it's not obvious where you need to pass it, whereas if it's required at construction time, you get a nice compiler error when you try to instantiate it. So I think there's an argument to be made for requiring it, and for the kind of exceptional case of when you don't actually have any useful data to require you to take an extra line.
Okay.
Just want to put that.
Yeah, so I will say that we're definitely going to have an API for updating the edge weights by applying an evaluator, because that's kind of a design goal, is that we don't need to reinitialize PageRank from scratch when the user changes something. But I think you make a really good point that it's in some ways simpler to just require it at construction time, and in the event that you don't have a use for it, you can just provide the lambda that every edge goes to 1, 1. Okay, I think you've persuaded me of that, so let's try it. Which will be an edge evaluator. But the semantic, because we can't guarantee that the user will provide an edge evaluator that actually is defined for every edge, Although I guess actually no, the type signature for edge evaluator is that it gives you an edge weight, not an optional edge weight. So I guess we can assume that you actually we do get an edge for weight for every edge. Provides the initial edge weight for every edge. Okay, and then we can go and initialize it, and we'll do, you know, for const edge of this dot graph dot edges this dot edge weights dot set, and yes, this needs to go here, edge dot address and edge evaluator on the edge. Okay. Now it's not okay. Let's see. That's I have a type error. Oh, of course, our tests are all wrong because we didn't provide edge evaluators. That makes sense. Pagra test. So now we can just do like const default evaluator equals unused edge goes to 2 1 row 1. Property fro is missing an edge weight, but exists.
I think it's fro weight.
Fro weight. That's right.
Oh, it's over there. Okay.
Yeah. Okay, cool. So that just worked. Now, we don't really have a way to test this right now. Do we want to have a method for iterating, for just getting all of these edge weights back? Oh, but you know what? The edges method should give that. So let's look at the original API that I proposed here. And what was my API for edges? Iterator over weighted edge. And the weighted edge has the edge weight. Yes? Yeah. So that's actually a fine way to do that. Edges. Iterator weighted edge. We'll again verify there's no graph modification. And this is now really important, right? Because if the graph were modified, then there would potentially be an edge that had no edge weight set because we didn't even actually save the evaluator function. But that's why it's great that we're doing this this verification edges iterator. Now let's just see how similar does this wind up being. Okay, so if I just go and say change node to edge, then no, but it's a weighted edge. For every edge, this weight, this is called edge weights. And we need to get the edge dot address, and then we yield the edge and the weight. Let's see how that looks from a typing perspective. And we need to define a weighted edge type. And let's of course make them read-only and exact. I wish we had a lint rule for like read-only exact.
Objects will become exact by default in the in a shortly future version of Flow. So.
Oh, that's nice. Cannot yield object literal because property throw weight is missing in weighted edge. What did I do wrong? Whoops, that's also not right. Edge weight, weighted edge. I must have some types that are wrong. So edge weights goes from edge address T to weighted. Oh,
You have
yeah.
weight is weighted at, yeah, okay.
Yeah. Whoops. An understandable mistake. These are fairly similar names. There we go. That should fix it, right? Great. Okay, so I realize now that actually our testing is incomplete, right? We tested that the scores are probably distribution. We never actually tested that this nodes method returns the nodes in the graph. It could return some, I don't know, some weird other nodes. So let's just go and add a test for that. Describe nodes. It returns the same nodes as are in the graph. So const g equals advanced graph dot advanced graph 1. Const pg equals new PageRankGraph default evaluator. Okay, now how do we want to do this? We want to test that the sets are equal, right? So const graph nodes equals. Can I turn an iterator directly into a set? Will the set constructor take an iterator?
Yes.
Equals set of g.nodes. It's so great having the William API available to me again. It saves me like having to go and look at documentation and stuff. Yeah. I highly recommend to anyone to try to get William as a pair programming buddy. Great resource to have on hand.
William, do you just like read a lot of documentation? Is that how you know stuff like that?
I definitely do read the documentation. I don't know. It's like, I don't know. I've used it a fair amount. I don't know.
Mm-hmm. In JavaScript land, is documentation, I'm reading like the Mozilla documentation
Yeah,
right now.
MDN is the
Okay.
way to go.
Yeah.
Okay, but I can't. How do I map over an iterator? This is one of those things that's like kind of obnoxious, right? Yeah.
Yeah, you're screwed. You can't. Go right
Yeah.
up from.
This is so.
But you can just assert set equality if that's what you wanted to do. Like Jest will handle that.
Sorry.
Oh
what
no,
do you
I
mean?
see. I see.
Yeah.
You need to map up. Yeah.
Yeah,
got it.
exactly. So I can say like const pg nodes equals array.from of pg.nodes dot map of x goes to x.node, and then I make that whole thing a set, right? Expect graph nodes dot to equal pg nodes. So what I haven't done here is I haven't verified that the scores are uniform distribution. I verified that they sum to 1, but they could have been any other distribution. So we should probably test that too.
You also haven't checked multiplicity. One of them could have a bunch of duplicate nodes.
Oh yeah, so check that the lengths are the same prior to, yeah. Okay, so maybe you should make graph nodes be the array, and we'll do the set equality separately. So I'll do expect graph nodes dot length dot to equal pg nodes dot length. And I know I could have used to have length, but I think this is a little bit cleaner because it's symmetrical. And then let's cool. So we're checking the set equality and we're checking they have the same length. That look good, William? Set requires new, sure.
Yeah, you need those.
Okay, and we'll do it nodes have uniform distribution at graph construction. And now we can do, I think we can just yank that, duplicate it, and all those tests are passing. And so now let's also do some tests on the edge. And I think the tests will be broadly similar. We want to test, well, for this we just need to test that the returns the same edges. And here, let's just start by subbing the word node for edge in a case respecting way. Vim has all of these nice little features like that. Well, mainly that's from a plugin. Okay, so we're getting the graph edges, we're getting the PageRankGraph edges, we're checking the length are the same, we're checking the set. But here we need to set equality on the addresses, not on the edges. But we do want to actually check the edges for equality, so do we sort by the edge address and then test equality? I wish we could write objects and sets. Cue a little lecture rant from William on like value versus reference semantics and how it's JavaScript's fundamental mistake.
Wait, sorry, did you actually want me to talk about that? Or?
You can go over that. I'd be curious.
Yeah, I think people would find it interesting. I find
Yeah.
it interesting.
Okay. So first of all, what we mean when we say value and reference semantics are, if I create an object that has property x:1, and then I create another object that has property x:1, we say that they have the same value, but they're different references, right? Like in memory, they exist in two different places, but semantically what they represent is the same. And if you do kind of a deep equality, you can't tell the difference except by noting that their memory addresses are different. And in JavaScript, we use equals 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 to test for reference equality. And for value equality, it like depends on the type, because
Do we have a helper function that does that? This is deep equal. Have I seen that?
Yeah, that's a great question. Lodash.deep equal, deep equal comes from Lodash, it will perform structural deep value equality checking, but that's not always what you want for value equality. For instance,
Okay.
you have two graphs that have different representations because the nodes were added in different orders or something, actually, I guess our representation preserves that. But like, it would be valid for a graph representation to have different internal representations of the same value. So types that admit a semantics of what value equality means should provide an equals method, because it really depends on the implementation. Right, so triple equals operator for reference equality equals like a custom equals method for value equality. And since it has to be a custom equals method, or it doesn't make sense in general, it sometimes makes sense, but not always, to do with deep structural equality. JavaScript doesn't do that ever. You won't find any primitives in the JavaScript standard library, such as it is, that do any deep operations. And since there aren't any deep operations, everything in sets and maps is keyed by reference equality. So that means if I have these objects that both have x:1, and I put them, but they're different in memory, and I put them both in a set, the set size will be 2. And it also means if I want to use them as keys in a map, I need, there'll be different keys. So like a common thing that you want to do in a map is say that you're representing people by name and birthday, which is an object with 2 keys. If I know someone's name and I know someone's birthday, and they're keyed in a map by an object of name and birthday, just because I know the name and birthday does not suffice for me to get them out of the map, because not only do I have to construct an object that has the name and birthday, I need to construct the same object in memory that has the right name and birthday. And that is kind of to get that, you would need a nice map. So this is one reason that I find that maps in JavaScript are, if you're not mapping from strings, if you want to map from something other than what is semantically a string, then you have a really hard time. Is this making sense? Are there questions so far?
Can you give a quick example of how this is implemented differently in another language that is more reasonable sounding to you?
Yeah, that's a great question. So I can mention what Java does. I don't think Java's solution is perfect, but I think it's very good. In Java, everything is an instance of a class, right? You don't just have bare objects. And all classes inherit from the root type object. And object defines some methods. It has 10 of them. But one of the most important methods that it defines is equals. So in Java, every object has an equals method that can be used to test its like that object's specific value equality implementation. So if graph has something that's not just structural equality like we discussed before, it can have like the right semantics there. So Java at like the type level has guaranteed that everything provides some implementation of equals, and if you don't provide it, it defaults to reference equality, which is like fine in many cases. So since this is part of the standard library and every type has an equals method, all the Java standard libraries like collections use that, and things are keyed by value, which is pretty much always what you want. There are types in the Java standard library that are explicitly keyed by reference, like you can have a map keyed by reference, but most people don't know that they exist because you never want them. It's not what you want to do. Yeah, like I said, I think this solution is good. It's kind of weird to have equals on all types because sometimes like it doesn't make sense. Like there are two things and it doesn't make sense to ask whether one of them is equal to another. And you're kind of forcing them to have a dummy implementation that always says no or like says yes only if they're also reference equal or something. But it's a really good practical solution. Haskell takes a kind of similar approach, which is instead of having an equals method on a root class, which Haskell does not have, there is basically an interface called eq. And if your object type implements eq, then it provides an equals function. And then maps and sets can only be used with things that provide an equals function. Does that answer your question? Cool. Yeah, the other main reason that maps are not used, or maps are not keyed by value equality, like in JavaScript, the ES standards people could have chosen to implement value equality by deep equality and use that for map keys and set values. But you also have the problem of like, what if the keys are mutated? It's like you can't really implement a map in the face of key types that are mutable. And so what Java does is they have another method called hashcode, which is like sufficient to solve this problem. And the JavaScript people, like it's because of the way that JavaScript is designed, it's hard for them to say like, okay, now there's this method called equals that everything supports, because if you already had something called equals, then now it's like backward incompatible, and they really don't want to break the web. And so given that there were these two problems with value equality and key mutation, they opted to take the easy solution of allowing maps keyed by reference equality only. And what reference equality means usefully in JavaScript is strings, which are only like kind of strings. JavaScript strings are UTF-16, which is a little strange, and floating point numbers, because as you will recall, JavaScript does not have a concept of integers. And also Booleans, but like mapping from Booleans isn't that useful. So this is why you will see in some places in the SourceCred code base, we have like our addresses are represented internally as strings, which is very strange, and it's like not something that you would design from first principles. And it also means that like you can't have null bytes in your addresses. But the reason that we do that is because we really want to use addresses in maps. And so you kind of get this effect where all parts of your system that might possibly be need to use as a key in a map, which is pretty much everything, need to be interconvertible with strings, and you need to do this at runtime, and it's kind of expensive, and it can warp your designs. So I think this is really bad. But it's what we have to live with. And there are like in cases like this where we want to where we're comfortable accepting a solution that might have poor performance because it's like a test on a very small set. You can, and you're sufficient to have deep equality. You can just like JSON stringify everything with stable stringify, and then use that as your key. And that might be what Dandelion's about to do. I'm not sure. I'll turn it back to you.
Also to say, guys, I accidentally, I wanted to try to get William's face into the screencast, so I tried to drag my little zoom icon that had badge with the faces onto my main screen, and I instead just lost track of it entirely. I can't find it anywhere. So I can no longer see, anytime you're like nodding or thumbs upping at me, you now need to actually say something, because Zoom is weird. So William, I had not actually considered the stable stringify approach, although that is actually a perfectly fine approach. What I was going to do is I was just going to sort them by the edge address and then assert that the arrays are equal.
That is also fine.
Yeah.
Well, I mean, there's kind of a downside to that in that. Well, yeah, I guess it's not really a downside. What I'm thinking of is that if like if the output of the method is wrong in that it gives you two edges with the same address but distinct contents, like that shouldn't happen. That's a bug in the implementation. But your like test will not necessarily be deterministic on that. But it will fail anyway, so I guess it's fine.
Yeah, I think that I do see the benefits to your approach on that point, and that it's like more robust to certain kind of errors. It also is just simpler because it means I don't need to like invoke sort by twice. I can just like let the canonicalization be done by stable stringify. So let's do that. Let's just like, what is it? Import stringify from JSON stable stringify. Is that it?
Yes.
I think that's it. Yeah. See, again, the William API, like it's even faster than Flow. Okay, so let's do that. Let's do expect stringify of graph edges that to equal stringify of PG. No, this won't work because
this won't work.
Yeah.
You would have to sort by on the stringify.
Yeah, I need to sort it. I need to sort it nonetheless.
The reason, to be clear, this won't work is that the arrays are not going to be sorted by stable stringify. It just orders keys in a map.
Yeah. So I do need to then, I either way I need to get, so I may as well just do the equality testing. If I'm going to like import sort by from lodash.sortby, I think that's it. It always bothers me that Lodash doesn't capitalize the words in the module names, but I'm sure there's some reason for that. Okay, so now we're going to say expect. Okay, wait. Why are these tests actually passing? Expect a new set of graph edges to equal new set of PG edges. What does that even mean?
So it's using reference equality semantics. You're returning the literal same edges in memory in the PG graph and the graph. But this is like not something that can be relied upon.
Yeah, it's not, at least at the very least, it's not something that should be relied upon. Yeah, so expect sort by of graph edges x const address accessor equals x, which is an edge, goes to x.address. And now we're going to expect the sorted graph edges, which is graph edges and address accessor dot to equal sort by PG edges address accessor. Okay, so that should just work. Cannot resolve name edge. Well, there we go. It's another import. But I feel like this would be actually a little bit easier to read if I did const sorted graph edges equals delete %. Will that work? Yeah.
Lord, okay, yeah.
And once again, prettier will fix all my weird indentation. Okay, cool. So the edges, so it returns the same edges in the graph, and we also need to test that it actually got the edge weights right. So we should probably have like a funky edge weight function that gives interesting quote-unquote edge weights. And I wonder what would be a good funky edge weight function.
You could use something like the number of characters in the name.
Yeah, that's a good idea. I think I've actually done that before. It returns the edge weights faithfully. Address source test goes to return to weight will be address.length plus source.length. For weight will be address.length plus test.length. And now const g equals advanced graph.graph1. Const pg equals new PageRank graph of g and edge evaluator. And now we're going to do for const edge weight of pg.edges. Okay, adios, William. Great having you.
Thanks. Bye.
We're going to do edge expect edge evaluator of the edge dot to equal the weight that we provided. Okay, cool. And that passed. So far so good. We've got now our edges and nodes methods, and they are both tested. Any questions?
How are you testing these so fast? Did you put a flag in the on Jest to like run the tests every time you make a change or something?
Yeah, here, look. What I did was yarn unit PagerankGraph. So the reason PagerankGraph is that's just a filter on the file names to test. So we're only running the test for this file. And then -- watch makes it refresh every time the file is modified.
Oh, okay. That's nice.
Yeah, so this is part of my regular development flow. What I actually would normally do is I would have this testing. I've got 2 monitors, and my second monitor would have the test and flow. And so I'd have more screen real estate, but since I'm screencasting, I just put it all on this one screen. But I love having flow and the test running as I code. It just like makes it so much more efficient. So. Okay, this is pretty cool. Let's go and make another commit. It's just a really nice practice to be committing regularly whenever you're in a good state. And I can even just go and amend the last commit. Has scores so I just amended that single commit. You know, I could have made another commit, but it tends to be kind of a mess if you have all these little commits, if they're not really like there's no sense in which will want the first commit and not this. It's like continuing work on the same little piece. So I'm just going to keep on updating my commit. So what do I want to do next? So we could obviously go and put in the PageRank, and I think that'd be a pretty interesting thing to do. We could also keep on building the infrastructure around PageRank, and like there's just more APIs like doing equality testing and doing serialization, doing reweighting. Any audience votes between sort of putting in PageRank, putting in equality testing and serialization and other utilities, and putting in changing the edge weights.
So a vote on my part for PageRank, though I also need to cut out in 12 or so minutes. So
cool. All right, yeah. Let's do some PageRank. Let's see how that goes. So let's take another look at my design doc here. Okay, so what I proposed was this async run PageRank method. Yeah, that should be interesting. Let's try it. Okay, so let's first start by just copying in the code that I wrote before. And we're going to have a convergence result type. What's a convergence? Convergence options and convergence report. So we'll put them up here. I really wish that you could just define types like inline in a class so that you wouldn't have to like go back to the top of the file to figure out what this convergence report is. But unfortunately you can't. Convergence option. Oh, I messed up something here. What did I mess up? Promise. It looks like it's here. Unexpected identifier. Does it have to do with the fact that it's async? What's wrong? Oh, async was misspelled. Yeah, okay. So let's how should probably call it like PageRank convergence options just to be clearer. So it's interesting, like having the time elapsed in milliseconds. I think I'm actually going to take that out for now, for the simple reason that it's going to be annoying to test. Like the iterations in final delta should be constant because the algorithm is deterministic, and so we could just snapshot test that, and it's kind of a nice thing to just verify that the PageRank implementation isn't changing. The time elapsed is going to depend on the machine it's running on, so let's just take that out for now. And we don't need it at the moment. Okay, so we want to run PageRank. Let's see how we do that right now. So we have this analysis PageRank method, and it's got some similar kind of stuff. Okay, so what do we do? Looks like we need to call create connections. Okay, I'm gonna turn off our testing because I just want another window to graph to Markov chain, create connections. Interesting. So we already can see this is like a little bit funky because this wants an edge evaluator rather than like a map of edge weights. But as William pointed out earlier in the call, it's not hard to translate between the two. And I don't want to have to rewrite this interface right now. So let's just call into it. We'll do const connections equals create connections on this dot underscore graph and edge evaluator, and this dot synthetic loop weight. Edge evaluator equals, we take x with it as an edge, and we go to null util dot get of this dot edge weights dot get x dot address, and we need to import create connections from, well, I think it's just safe to say we're going to want all of this stuff imported, except we don't need just /attribution, oops, because that's the folder we're in. Okay. So we're creating the connections, and then we need to make it into a Markov chain. It's nice that I can just copy and paste from an existing invocation. Ah, yes, and now yield after MS. What is that? Let's take a look. So find stationary. No, that's in a different folder. That's in Markov. Find stationary distribution. What is yield after MS? Ah, it's not. Okay, interesting. So it looks like we have a feature that, like, after a certain number of milliseconds, it will just give up regardless of the number of iterations that have occurred. And I don't want that to happen here right now, if only because I don't know. I guess we've just never really used that option. Yield after. Oh no 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 no! I forgot what this is. This is why we need documentation. Yield after milliseconds. It doesn't. So it does. This is where every 30 milliseconds, the function will give up control, so that if you're trying to like change the UI, so it doesn't block the main JavaScript thread. So this doesn't control how like long the computation will run for per se. It controls how long the computation will block for at any given time. And so every 30 milliseconds, it will like let any other computation that the browser is trying to do on this page go through. So we don't really need to worry about that right now. I'm not going to expose that as an option. That's just like kind of an implementation detail that makes sure PageRank won't lock the UI. So now we can go and take this. I'm going to set verbose equals false for now because we haven't made that an option. The convergence threshold is going to be, just options.convergence threshold. And the max iteration is going to be options.max iterations. Yield after MS, we'll sure leave that at 30. And but we need to import find stationary distribution. Cannot declare type edge weight because we imported it here. Got it. So we no longer need that import. And 137. Oh right, because I called it PageRank convergence options. And similarly, I called this PageRank convergence report. It's kind of long now, but that's okay. But we're not returning anything right now. So, interesting. I think that, yeah, to find a stationary distribution, the underlying method does not right now actually. So this convergence report that I wanted to put in, right now the underlying API doesn't allow me to do that. So I do want to get this data out. So I'm just going to make another stop ship for myself that says stop ship need to modify underlying API so that we can actually return this. So this way I'm not going to merge this code inadvertently because again, stop ship, having this string here means that we'll fail tests. And what this means is that I'm going to go and make another commit that just changes this function so that it gives you back the information that I need to make that report. And you know what I'm going to do also? I'm going to put a stop ship. This needs documentation because no one should have to try and figure out what that argument actually does because it's really not intuitive. Okay, but so now I'm just going to have this just be a promise of void because I am we don't have the right type there, and I just want to test the behavior except for that. Okay, so now we get the distribution as a probability distribution. What is the type of distribution? Okay. Got it. So the distribution is actually, so we're going to need to do some translation to get this distribution, which is just an array of floats, and map it back onto node addresses. And that will require a little bit of like careful work. Yeah, because we need to go and basically apply these to the scores. Now, when we call graph to Markov chain, we have this distribution type, okay? Where do we get the distribution? So, node to distribution. Here we get the node. So we really want a node distribution, not just a raw distribution. Where does a node distribution come from? Okay, we have a function for it, distribution to node distribution. And we need a node order. Well, where do we get a node order? Which is a read-only address of node address T. Okay, so the ordered sparse Markov chain has a node order. So let's get a const node distribution equals, where was it? It was called distribution. Yeah. And that's osmc.node order and our distribution. Okay. And now what we really want to do, we want to assign it to the scores, right? So you can go and say for const, and what was the node distribution again? It was a map from node address t to probability. Oh, interesting. So I think what we might want to just do is we might just want to replace the scores with this, because this is our new distribution. So we don't need to, we don't need to go and iterate over it again. That would be all unnecessary. You can say this dot underscores equals node distribution.
So sorry to interrupt.
Yeah.
I've got to hop. Thanks a lot for this dandelion, Brian. Nice to see you. I'll
Nice to
look forward to checking out this PR once it's in.
Cool. Yeah, it'll probably be a bunch of smaller pieces, and I will CC or add you as a reviewer on all of them.
Lovely. See ya.
See you. And okay, I think this might actually just be a working PageRank at this point. Yeah, the nice thing is, you know, that we have all the major pieces already coded, so it's just a matter of like putting them in a nicer API. Yeah, we've got no errors. So maybe let's test it. How do we want to test this? Excuse me, I'm about to sneeze. Okay, so I think that to test this, like, we could go and test the numerical values that come out of this, but the thing is we already have pretty good numerical testing on PageRank itself. So in some sense what we want to do is we just want to test that this code that like wrapped the stuff together worked as expected. And I would be particularly worried about making sure that the like node distribution stuff worked out. So what we could do is, okay, I wonder what William would think of this, but what I'm inclined to do is I'm inclined to create a really simple graph where it's just kind of obvious to us what the semantics should be, and then just test that we got approximately the right stuff as a result. So let's try this. You know, describe run PageRank, and we'll say it should have uniform distribution after 0 iterations. So here we're going to say const g equals advanced graph dot graph1, const pg equals new PageRank graph of g and default evaluator, and now yeah, okay, so we'll do pg dot run PageRank of max iterations 0, convergence threshold, I don't know, 1. Or let's actually say 0 because it doesn't matter. And now we'll have const other pg equals new PageRank graph of g. You know what would be helpful right now if we had the equality method defined. But I tell you what, let's just make a really simple graph. I don't want to use this advanced graph because it's too complicated. So let's have, you know, function simple graph, which I'll just annotate it returns a graph. Const foo equals node address dot from parts of foo. Const bar equals node address dot from parts of bar. And let's just have a single edge going from foo to bar. Const edge equals address edge address dot from parts of foo bar, I guess. Source is foo, dest is bar, g.add node foo, add node bar, add edge edge. Now return graph foo bar edge. Let's just rename this to graph. Rename this to graph. Okay, and so let's say const graph foo bar edge equals simple graph. Let's do that. Let's run PageRank. And now we are going to expect. Ooh, you know what? Okay. So this is something interesting. This happens a lot as I'm writing test code. So one of the really great things about sorry, let me fix the syntax error. Edge. Okay, I did the thing with the paren in the wrong spot again. One of the really great things about writing test code is that you figure out what APIs you need, because you often need APIs to write reasonable test code. And right now, the test code that is going on here, oh, that's right, no, it doesn't return a graph anymore. Okay, so this test code is going to be a lot cleaner to write if we have a couple more methods on the PageRank So what I really want is like a node method that gives you the scored node given the node address. So node of, and it maybe gives you a scored node because it could be null. And then, as always, we'll check that the graph is not modified. And since we're adding a new method, let's like check that the graph modification check applies here. Yeah, function verify errors thrown on G is a PG is a PagerangGraph. Because we're adding a new method, I want to make sure that it also fails if you call, and now we'll use node address.empty because it doesn't matter. And now we will do verify errors thrown. And this way we are not just like keeping two copies of this, you know, don't repeat yourself. Classic programmer aphorism. And this node method is going to, let's see, if const score equals this dot scores dot get of x, if score is null, actually just do return null util dot else. No, we want to do if score equals null, return null, or else return node. Let's just call this. No, that'd be kind of confusing that the function is called node and takes node as an argument, so let's not do that. Node colon x and score. And let's test this method lest we forget. Describe node. It returns null for node not in the graph. And that will be const G equals new graph, PageRank of G and default evaluator. Expects pg.node of node address.empty to equal null. And it returns node and score for node in the graph. Const G equals new graph. N equals node address. You can even just use the empty address, it doesn't really matter. G equals new graph to add node of N. Const PG equals new PageRank graph of G and default evaluator. And and then expect pg.node n to equal node n and score 1. Let's see if those tests pass. Okay, property node is missing because I didn't save over here. 104, typo. Whoops. Okay, seems like I used to call it PRG instead of PG, but I think PG is better. Okay, cool. So. Oh yeah, that's right, I wanted to run the tests. Okay. Oh, it took a little while. That was kind of sketchy. I thought maybe it got stuck in a loop forever. Returns null for... So some of this stuff took like 16 milliseconds for a test, but I think that's probably just spurious or something. I'll worry about that later. But great, those tests are passing. So now we can go back to testing the PagerankGraph behavior. So we have the simple graph method. Okay, so should have a uniform distribution up to 0 iterations. So now we're saying expect pg.node of foo to equal node foo score 0.5, and the same for foo as for bar. And let's see what happens. Yep. Okay, it should converge all weight to bar. So again, we know that the only edge in the graph points from foo to bar. So let's go and say, okay, we're going to run it for up to 1,000 iterations with a convergence threshold of 0.001 maybe. And we're going to expect pg.node of foo.score and .score, and here we're going to have to use to be close to 0 and to be close to 1. Let's do 5 digits of precision because, or no, let's do 3 digits of precision. Just be a little generous with it. Okay, now we're getting a real test of the PageRank behavior. Let's see if this works. Of course, okay, because yeah, you're right, Flo, technically speaking. And now I need to import null util. Okay, no errors, and it did not pass. Okay, great. Now we're learning that PageRank doesn't work. So that's good to know. What went wrong? Okay, so what we're seeing is that we expected it to be close to 0, and it actually got 0.5, which suggests that PageRank just didn't, like, nothing happened. Oh, of course. And the reason is because this is an async function, and we didn't actually, like, await it. So let's make this async, and let's await PageRank to finish. Okay, but it still didn't work. Now something happened, but not anything good. What is going on? How interesting. So we're getting the new distribution, we're converting it to a node distribution, we're assigning the stud scores to it. Let's say we're going to just console.error distribution at this point. And what gets written to console here? Nothing. Well, that's interesting. It's not what I expected. Are we even calling this function? Let's just put like a print at the top. Console.error run PageRank. Oh, here we go. Okay, no. So we were doing it. It just got lost. So I'm gonna do it's dot only here, because right now we only care about this test, and that way we just won't have the noise of the other tests passing. Okay. So wait, but okay, why is it not printing? I'm not consistently seeing this console.error that I expect to see. I'm going to just close that and rerun it and just see whether... I don't know. I'm just a little bit confused right now, TBH. It's like not really making sense to me what's happening. Okay. So... yeah. Clear? I'm going to even just make a new window for this. Okay, so it looks like it is running PageRank, and it is finding a stationary, trying to find the stationary distribution, and it's getting its options.conversions threshold and options.max iterations. And I set the conversions threshold to something small and the max iterations to something large. And did we actually add the edge to the graph? There's a question for you. Simple graph, yeah. No, I added added these edges. The edge. Oh, of course. This is so silly. Okay, you remember we made our default edge has a to weight of 1 and a fro weight of 1. And so we actually have a graph that is totally symmetrical. And so when PageRank converges, it's going to put all the weight equally between the two. So that is actually just working as intended. This is exactly what the graph converges to. So we need to use some more interesting edge evaluator. Yeah, the most confusing bugs are the ones where it's actually you are confused and the program is working entirely as expected.
Yeah.
So we'll console.error. We can delete these because it turns out that, whoops, there we go. Turns out that it was just working as intended. Okay, so let's say
we were expecting one of the nodes to have all of the cred and one of the nodes to have 0 cred.
Yes, but that's only because I was wrong.
Okay.
So here, let's make the const EE takes unused edge, which is an edge, and it goes to weight. Will be say 0.75. Fro weight will be 0.25. And now the weight on foo should be about 0.25, and the weight on fro should be on bar should be about 0.75, I think, because it will be kind of like putting. Will that be right? I think that will be right. Oh, well, I'm not using that evaluator. Oh, interesting. So that still didn't work. Okay, let's go back to the extreme case. We're going to have the edge be like entirely one way, so it sends all of its weight from foo to bar. So foo should have about 0, and bar should have about 1. Okay, so that passed. So that's cool. I'm still interested that my intuition was wrong about how that would work when the weights were. Okay. It's with max iterations equals 1. It doesn't converge. Yeah, that seems fine. So we'll say max iteration equals 1, and we're just going to run the same experiment, but now I expect, let's just see what values we get. Because it should be, oh, of course, because the two weight and fro weight are so extreme that it just goes. So let's do again this 0.25, and now let's see what happens after a single iteration. Yeah, so now I think we can say that'll be close to 0.5. Ah, yes, but we only, let's just say 1-digit precision. Cool. And we can say maybe with high convergence threshold, it doesn't converge. And so now we'll say the convergence threshold is 0.1. And let's see what happens there. Cool. And now let's say with low convergence threshold and high max iterations, converges.
You think people would ever set their own convergence threshold?
You know, it's a nice parameter to have it easy for us to tweak at the library at the program level. I don't think I doubt we'll let the user ever change the convergence threshold. I could imagine though that one thing we might do is we might have this workflow where you can go and twiddle the weights in the front end. We might want to make it so that in the front end, as you're experimenting with weights, it has a relatively relatively high convergence threshold, so it's just works fast. And then in the back end, when you're generating the true finalized credit distribution, that might have a much
that
lower
would be
convergence
interesting.
threshold. So then the front end would be kind of giving you approximate cred, and the back end would be giving you true cred, something like that. So let's set max iterations to 1000 and convergence threshold to say 1e -9. And now I think it should be a 25-75 split. That just makes sense, right? But let's see what it does. Okay. So what does this mean that I'm getting something so different than what I expect? I'm really confused by this. Is the algorithm wrong, or is my understanding of PageRank semantics wrong? I wish we had William. He would have a great insight, I'm sure.
He would know.
I'm going to just ping him and see if he is available to...
That thing you said today earlier about you corrected me in a comment about the node bringing weight versus flowing weight, or the semantics of that was pretty interesting too. I was just thinking that just now.
Oh. No, this is working as intended. Yeah. Okay. So this is pretty counterintuitive. But the weights only matter, except for the case where it was like the to weight was 1 and the fro weight was 0. The weights matter when one edge has multiple, when one node has multiple like out edges. So let me actually make a slightly different graph. I wish I could draw you a diagram right now to explain exactly what's going on. But basically, let's suppose let me make the graph better, and then I can explain it as I go along.
We might be able to, or might be able to edit this to put in a graph or something.
What do you mean by edit it to put in a graph?
Oh, I don't know. If we put the recording out, we could actually provide a graph.
That's an interesting idea. Yeah, I think that honestly, like, we should probably at some point do a recording that's just like diving into PageRank with examples to make it more intuitive.
That might be. I was thinking that too. That might be worth so that people, feel like they have a firm understanding on.
Yeah, and I think what we should do is I mean, it would be amazing if we made a little like UI that let you like build a simple graph in the UI and like see it and then like see what the PageRank semantics are. Maybe with like a D3 visualization.
I've seen those for algorithms. Yeah, it might not actually be that. It might not be impossible to do.
Yeah, once we have this is one of the things that having the PageRank graph will make it a lot easier to do that. But okay, for now the issue is I'm going to have const like root will be another node address dot from root, and we have root, foo, and bar, and the general scheme will be root goes to foo with weight 0.25, root goes to bar with weight, and it can be just 1, 2, root with weight 1, and bar goes to root with weight 1. And so what we should see here is, oh yeah, but see, again, like even with this simple graph, it's not totally obvious to me how the weight should accumulate. So let's see. So I think root should end up, and I almost wonder also if we should have a little like diagram, like root foo bar. And it's not easy to like draw a diagram of a graph in a comment. Yeah, but the other thing is I think we need to have, for the weights to be meaningful, we need to have multiple edges leaving one node. So let's just like try this and kind of see what we get, if this can like become a decent test case. But actually the weights, so let's do this. Let's have that be the simple graph. And let's have function simple PageRank_graph. Root, foo, bar, edge. But then we need 3 edges, right? This is getting more complicated. Okay, maybe no, but checking that the weights are incorporated properly is really important. Otherwise, we're not really testing the code we need to be testing. So I think there's no avoiding having this slightly more complicated case. So okay, we're gonna have const root foo equals. Okay, we'll have const nodes equals root foo bar. And we'll have root foo is going to be address, edge address dot from parts, root foo, source is root, dest is foo, root bar, const edges equals foo root bar. Okay, so we still only have 2 edges. That's not too bad. Okay. So that's our simple graph. Why am I getting a syntax error? Bar. Definitely confused at why we're getting this syntax error. Okay, property cannot return object literal. Function simple graph. I feel like I must have some weird syntax error. What happens if I just delete this return statement? And it returns nothing. Okay, but oh, I see. It's actually an error at a distance, because here we're expecting, got it. Nodes, edges. Okay, that should fix that flow error. I'm just going to go and fix up the current tests. So you know what I'm going to do next? I'm going to just specify, I'm going to make a function where you just tell it the exact weights that you want. Let's make this simple PageRank graph. And let's say that you have type PageRank edge weights equals, you've got root to foo is a number. You've got root to bar is a number. You've got foo to root is a number. And you've got bar to root as a number. And let's just specify these explicitly. Let's have const edge evaluator equals, and it's going to take e as an edge, and it's going to, if e.address equals root foo.address, then return to weight will be root to foo. Oh god, this is going to be confusing. Oh no, PageRank graph, so this will be weights. Got it. toWeight will be weights.rootFoo. FrowWeight will be weights.fooRoot. Then if e.address equals root bar.address, then it's the same but with bar instead of foo. And then throw new error unexpected edge address. Sure. And now const PageRankGraph equals new page. Sorry, that should be lowercase. Of graph and the edge evaluator. And now we can return that too. Okay, and so now you're just your job is to explicitly provide exactly the weights you want. And it's a little bit verbose, but it's just test code, so I think this is okay. Root foo 1, root bar 1, foo root 1, foo bar 1. Okay, that didn't work. Why not? Foo bar. Oh wait, we didn't. We just have root foo, root bar, foo root, and it's actually to bar root. There's no foo bar edge at all. Okay, I'm gonna make it G and PG for consistency. Because that's how I've done it elsewhere. Node. But you know what, I am going to have it just return root foo bar. We don't need this node's object as in a direction. That's just kind of annoying. And I don't think we even need to return these edges now. I don't think we're going to use them. So let's see. Oh, that's a syntax error, for sure. Okay, so now okay. Oh no. Okay, let me go and fix my many flow errors now. 113. This became simple. Oops, simple graph. PageRankGraph. Do you see? Yes, 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 yes. And now, of course, we have all of these other cases. Yeah, I guess I really just need to fix these tests one at a time. Okay, so yeah, if we do 0 iterations, then it should have a uniform distribution. If all weight points accumulates score. Okay, so now we're going to say, you know, we get the PG, and we also get foo bar root is simple PageRankGraph of okay, so we said we're going to have all weight points to root. So foo root 1, root foo 0, bar root 1, root bar 0. Now, yeah, we expect foo to get a score of 0. We expect bar to get a sort of 0. We expect root to get a score of 1. Now, let's see, it shouldn't converge, so let's have it be something that would take at least a couple steps to converge. So let's grab this again. And let's say now, okay, so it's all going to be 1, except when it meets root, it wants to go to bar. And so now foo let's see, so root wants to go to bar. So let's just say, let's see, I'm going to just speculate that it should still be close to 1/3 after a single iteration. I might be wrong. It might be that it actually converges quickly because it's a simple graph. So we'll see. But that's at least like the right type signature for the test. With high convergence threat, this is basically the same thing. It's just this time we're maybe putting max iterations as 1000, but the convergence threshold is very high. Let's make the convergence threshold 1, so it's just this is basically 1 iteration as well. But ooh, missing source and edge. Oh, I forgot to add some stuff to the. I probably forgot to add the root node to the graph. Yeah. Dot add node root. 153 has an error. Yeah, let's go and fix that. Oh, oops, need to grab all this. Okay, let's do something kind of cute. Expect pg.nodes to match inline snapshot. Let's see what that does. Wonder if William would approve. That's awful. Match inline snapshot object. Sure. That didn't really work, did it? Oh, of course. I need to expect stringify of that to match inline snapshot. Let's see how that works. Might have to do array from, well, okay, I need to import stringify. Well, you failed to locate this because I wanted you to write it. Let's try that. So -u for update snapshot, and hopefully it will now put in the inline snapshot for me. Couldn't locate all inline snapshots. Okay, well, you're kind of disappointing me, Jest, because you're supposed to just take care of this when I tell you to make an inline snapshot. Couldn't locate. I don't still have an it.only now. Is the issue that I need to do an array.from here, just speculatively? Let's try that. No, just can't locate the inline snapshot. Is this an async function? Yes, it is. Okay, let's just use this expect approach and not worry about why inline snapshot isn't working right now. So that should definitely fail. Okay, so let's see what our fails are. Okay. So with max iterations equals 1, it doesn't converge. And so I think the problem here is that this is actually like such a unbalanced graph that it actually converges pretty quickly. And in some sense, we are just testing the wrong thing here. You know, if we want to test, if we're trying to test that it only did 1 iteration, we should be testing that by looking at the output of that convergence report piece and not by like looking at the intermediate state of the graph, because then we're just like, you know, kind of coincidentally testing some random math. So maybe instead what I'll do is I'll just go ahead to Markov chain, and yeah, I tell you what, I'm going to save this, and I'm going to make another commit right now. And I'm going to commit work on run PageRank. Need to add an API to Markov chain so that it will properly return the, what am I trying to say here? Yeah, the convergence report information, the number of iterations, and so forth. Okay, now we're just going to make another branch, and we're just going to go and do that work that we want to depend on. Big part of the SourceCred style is like we prefer to have small commits that do like individual pieces of the project. So rather than like mixing together that work, I'm just going to go and do it separately and then rebase on top of it. So we want to go to find stationary distribution. And it returns a generator that returns a distribution. Thank you. What is this generator? Is that something that this looks like a built-in type? Yeah.
So Dandelion, if you were to commit this and you were to make this change to the helper function, I think you addressed this in the contributing guide, but would you like put the commit in with the helper, update the helper function, and just write in the commit message like, look, this is to help me do this other commit?
Yeah. So I would just be making a totally separate pull request for this helper commit.
Yeah.
But I would put in the description, I'd probably write like, yeah, the context for this change. I always like to put context in the commit message and in the pull
Okay,
request
the context for the change and explain. Okay.
Yeah. So this find stationary distribution generator, I think that, okay, so find stationary distribution gives a promise of a distribution. And I think I wanted to actually give a promise of like a distribution. So let's export type find stationary distribution result equals, and we'll call this a plus convergence report of type convergence report, and we'll call it a type distribution, a distribution of type distribution. And now this will be a promise of a distribution result, or a like, let's just call this a distribution result, I guess. It's kind of a weird name. You know, William can complain if he doesn't like the name. I'm sure if he doesn't find something better. Okay, and oh yeah, we need to have this convergence report. Type define import type convergence report. Okay, what to name this variable? So, you know, this is going, maybe we'll call this like n iterations, and we'll call this like convergence delta, and I'll just document. Okay, but what are the exact semantics here? How do we do this diffing? Okay, so we do promise. Okay, it's actually all up here in this generator, isn't it? Delta. How do we compute delta? Okay, fine. We do it via compute delta. Okay, so it's actually the maximum delta. So I need to, this needs documentation as well as options. The chain is considered to converge maximum delta and the distribution is less than convergence threshold. We will stop trying to converge after, or we will run max iterations of chain steps at most. The final maximum delta, the maximum delta between entries and the distribution, the final Markov chain step. Okay. So now we have this information, and we're obviously going to get a lot of type errors because we're not actually returning this thing that we claimed we were returning. So we've got to go to this function now. So actually I'm going to go and take these types and I'm just going to hoist them up to the top of the file more or less. You know, I kind of wonder if we just fold the distribution into this convergence report. Like, yeah, I think that'll be fine. Okay, I think that's a better name. And now we can go to interesting, you know, maybe here we actually want it to go from distribution, instead of distribution to distribution, we might want that to go from like distribution result. What did I call it? Stationary distribution result? Okay, so now this is a promise of a stationary distribution result. And now this find stationary distribution generator is a generator of a stationary distribution result. And let's see, so it starts with a uniform distribution, it computes a delta, it lets iteration equal 0. While true, we increase the delta, we iterate on the iterations. Okay, but so here if we return pi, we're actually going to do return distribution pi, and the n iterations equals iteration, and what was it? What did I call it? Convergence delta maybe is delta. Okay, so we might need to have, yeah, we're going to have testing for this. Let delta equal 0, because in the initial state we haven't actually taken any steps. And now delta will be there. Okay, I think that's actually sort of correct, but let's see where the tests are failing. Okay, great. Now it's failing outside of this file. because of course now we need to say no, that's not right, is it? Oh wait, got it. It's distribution. This is actually going to be distribution result. PageRank node decomp test MK1G result. PageRank node decomposition test. Let me turn map. Okay, so format a decomposition. So this is where if I had put in a type signature of what exactly it is I'm expecting here, this would be a little bit easier to deal with. So what is this function supposed to take? Okay, so wait, results of calling decompose page node decomp decompose. This returns a PageRank node decomposition, you don't say. So let's annotate that, because I think that we're getting an error from somewhere else actually. And let's import type PageRank node decomposition. Okay. So now we're getting an error somewhere else. Cannot get result.distribution. Okay, so now we're getting something kind of unfortunate, which is it's not really showing us the context for that error. Okay, so now we're seeing it. So we're looking for line 134 here. Yeah, okay, so we're getting this result. Got it. I rebounded the variable result, so that's just silly. Sure, let's call it distribution result. And let's call it decomposition. And now we are just getting less ambiguous all the time. And now let's watch flow again, see what else comes up. 154. Yeah, okay, so now we're again distribution results, and we want, yeah, I'm just going to call that, yeah, distribution result, fine. And let's just call this again decomposition. And now, do we just get to keep on doing this? 154. Yeah, where's this pi coming on? Oh, different file. So distribution. Here we can just call it results in context, I think. Expect stationary. Result distribution. Oh. Okay, so again, okay. No, 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 no. Yes, yes. No, yes, yes. No, yes. Okay, now That should fix up that file. No errors. Great. Let's see how our tests are doing. So even if the tests pass, we're not done because we haven't actually tested the new behavior that I added. But if the tests are passing, that's a good start because it suggests I didn't, like, at the very least, I didn't break anything. Okay, cool. Tests are passing, which, as I said, is a good start. Now we just need to understand the test in this file well enough to add a new test. And the new test will be the test that it actually, yeah. Okay, so result. Now let's see. So how many steps does this take? I'm really curious. Expect results dot convergence delta dot to be less than or equal 1e negative 7. Expect result dot n iteration to be less than or equal 255. So that should certainly be true, you know? I wonder if I'm just kind of curious. I'm going to say expect result dot convergence delta dot to match inline snapshot. Interesting. Okay, so it converged well, and it took 51 iterations. And so, you know, I'm not sure what William will think of this, and I will look forward to seeing what he says on code review. But this should actually be an invariant of, this should be totally deterministic. So I think having an inline snapshot is fine. Okay. So that's interesting. Let's just go and do that a few more times, eh? Because, you know, here we know it should. Returns initial distribution 2 equal 0, and expect result dot convergence delta to be, this is interesting. Okay, what should the value be when it's 0? Because, like, I think right as implemented it's going to return 0, but I think it should actually return, like, not a number, actually, because it's just like we don't have a value for that. And of course, all of our snapshot tests are going to fail because we need to update them because I just copied the literal. Okay, so this is something that Jest does sometimes. If you look at the list of tests that it ran, it's in watch mode, and it did not actually rerun the test that we modified. I hate it that Jest does that. It just, like, does not make any sense to me. And, like, Facebook writes good code. I'm not sure why Jest has that behavior. It just seems totally broken to me. And I've learned just, if sometimes Jest will just pass when I know it should have failed.
Wait, if the watch flag is on, it does what?
So if the watch flag is on, sometimes it just doesn't watch the test that is actually the test that you were changing for reasons. So it'll just spuriously pass because it, like, ran some other unrelated test and didn't actually run the one that you changed.
Interesting.
Okay, so let delta equals not a number. And I'm just going to put the document it. Okay, now we'll update the snapshots again. Got it. Okay. So here we actually we know exactly what the values will be. So having the snapshot test there is redundant. Here, let's see. Find stationary distribution of a periodic chain. So what happened here? So it actually converged after a single iteration. That is interesting. Huh. Oh, I guess I can see why that is. Yeah, because after it started at that distribution, it took a single step, it produced no delta, so yeah, that makes sense. And here with this non-degenerate stationary distribution, node 0 is the center, nodes 1 through 4 are satellites. William wrote this code. A satellite transitions to the center with probability 0.5 or to a cyclically adjacent satellite with probability 0.25 each. The center transitions uniformly to a random satellite. And interesting. So it gets a very small delta after 22 iterations. Yeah, that seems reasonable. Okay, I think this is actually fine. I feel like this code, this seems pretty persuasively correct, and I actually like reading this test code and having this convergence information, which I think William will like it too. We'll see. This is the kind of thing that I will just like, I'll CC it to other people, but it'll be really William whose review feedback I want since he wrote this module. Okay, let's PR this, or we'll create the PR and then we'll I like to read it in the GitHub UI. Modify find stationary. Get a convergence report from find stationary distribution. Will that fit? No. Report Markov chain convergence statistics. Sure. This commit modifies Markov chain find stationary distribution so that in addition to returning the final distribution, it also provides information on many iterations were required to get that distribution, and on what the final convergence delta was. This will be useful for, this is motivated by the proposed API for the new PageRank See, where's that issue? Oh, this one. Test plan. Tasks are updated and yarn test passes. For let's say semi-pair programming it. Okay, let's just take a quick look at the diffs here before I send it out, before I push it. Distribution results, set, importing some stuff. Just added some types there so it's a little cleaner. Yeah, that looks fine. That looks fine. Okay. You know what though? Actually, for this one where it's 0 and 1, rather than having an inline snapshot, I will just explicitly expect that to be the case because that's an invariant of the test itself. Cool. It's always good to do that kind of self-review. And, you know, I actually said in the test that I would run your own test, so I should do what I said I would do and run your own test. Cool. And now I'm pushing it, and now we go here, and here. Oh, I had a question on the Twitch. Whoops, I wasn't watching it. My keyboard is a what is it? It's a Havit gaming keyboard. I'm going to hold it up to the screen. This is a really sweet keyboard. It's quite small. It fits nicely in my backpack because I like to travel with it. It's got this cool, it's got like a bunch of different settings for how the lights on the keyboard are controlled. Right now I've got in this sort of like matrix rain pattern, but it's got tons of configurability. It's really a pleasure to type on. It makes, I like the clicking sound that it makes. I get actually a lot of compliments when I'm typing on it. People are like, oh wow, you're like such a hacker or something because of how it sounds when you type on it. So I'm really fond of it. What is this project about? Great question. This project is basically, it's our attempt to make a like credit attribution, a reputation system for open source projects. So you can see here is like on SourceCred, we run SourceCred and it tells us who has contributed the most to SourceCred. And so you can see, for example, that like really William and I have like contributed a whole ton. I got other people like Brian and Anna are kind of moving up in the rankings. This one on the website is a little bit outdated. I'm almost certain that if we were to like let's see, what's this local copy? We don't have the date. The date thing didn't merge yet, which is too bad. But yeah, I have a feeling that if I reran this data, I know like Brian and Anna have been active a lot lately. Also, we can run it on SourceCred/mission. Yeah. But the basic idea is we have a fancy algorithm we run over the whole history of all of the interaction that has happened on the project, and we try to use that to figure out who has made the most contributions to it. In the very long run, there's a vision about using this to be able to like flow financial value, either in the form of like donation dollars or cryptocurrencies to the people who have contributed to a project. And it's still pretty in early stages where we're just trying to get the algorithm to really work effectively. Okay, so we have this pull request on this Markov chain stuff. I'm going to test that the markdown links work properly. Yep, they do. Brian, I'll add you as a reviewer since you have watched this all happening. And it's a pretty straightforward pull request. And we'll send that off. Also, I'll say to Jay Louise, who's visiting on Twitch, you're also, if you find you can find our Discord here. Yeah, if you want to join the Zoom meeting, there's a link in the Discord. You're also just welcome to keep following along on Twitch. Okay, so I'm kind of running low on steam here. But let's go, at the very least, let's just try to get the actual PageRankGraph commit to use this new code, because that would be cool. So, going to go to PageRankGraph, and now, sorry, this is the wrong one. I called it live coding. Yeah, live coding PageRankGraph. Okay, and so now we're going to interactively rebase this on the commit that we just made that did the cool stuff with the Markov chain, so that we can take advantage of that code we just wrote. So what did I call that branch? I probably called it like something, let's grep for Markov. No, let's grep for report. Maybe I called it convergence report. Yeah. Okay, so rebase -I convergence report. And yeah, we just want these two commits on top of the convergence report. So now we can log and we can see, okay, this report Markov chain convergence statistics commit made it in. And we may recall that over in the PageRank graph, we had this stop ship. So we wanted to modify the underlying API so we can actually return that. So let's do that. And let's go to the run PageRank method. And we're going to make this a promise to return the PageRank convergence report. Let's just make some more space here. It's kind of long. Okay, and so now we've got a flow error, which is great. That's to be expected. But now, so this is actually no longer a distribution. It's a result, a distribution result, let's call it. And now the distribution result.distribution, and we can even just elide there's no need for this extra declaration. We get this dot scores equals that. And now, what we want to do is we want to return this convergence report. So we're going to return convergence delta will be distribution result dot convergence delta, and n iterations will be distribution result dot iterations. And probably named, I named it something different here, but I like consistency, so let's just call this n iteration. And let's just call this convergence delta. Okay, cool. So now we don't have any flow errors. And now we can go to our PageRankGraph test. No, I mistyped that. And now we can, so now this is great. We shouldn't be testing PageRank semantics here, right? That's just a little bit silly. We already have thorough testing of that. Maybe I'll keep this test case just because it's like nice illustration, but now we don't have to do so much. So we can say after 0 iterations, so we're going to run PageRank, do const result equals await. This needs to be async too, async. And now we can expect, that it's going to have a uniform result, or you can expect result.n iterations .to equal 0, and expect result.convergence delta to equal none. Okay, if all the weight points to root, it accumulates score. So like this, again, this is the kind of test that now it's like not super clear we actually want it, but it can't hurt. And so, let's just do to match inline snapshot again, and let's just see what this comes out to. Not clear that we should be testing that here, but let's see what we got. Okay, we're now testing the wrong file, so we'll have to watch PageRankGraph. Okay, cool. So it did 3 iterations, and it let's see, all weight points to root, hit accumulate score. Yeah, that worked. With max iterations 1, it doesn't converge. So yeah, so now we don't even need to look at the things here, right? We can just go and say const result equals, and now we could just expect result dot n iterations dot to equal 1, and expect result dot convergence delta to be greater than the threshold, which is constant threshold equals 1 negative 5, say. Just make that threshold, make that and what are we getting here? Okay, cool. With high convergence threshold, it doesn't converge. Yeah. I feel like these tests are kind of dumb because, like, what are we really testing here? Like, the fact that we're giving weights to the graph. I'm gonna just sort of check here with low. So again, what do we really want to test here? We want to test that we want to test that we composed the Markov chain functions correctly. I often struggle to decide how to test this kind of glue code. So what we could just do is, we have this test that, like, if all the weights point to root, then all the score goes to root, and I kind of like that. Okay, I guess I don't mind having this test here, where it's just like testing that the options got consumed correctly. So let's do const result, or you can even actually do const convergence delta and iterations equals that, and expect convergence delta dot to be close to 0, 3 zeros, and expect n iterations to be less than 1000. And okay, we can say, for example, that, like, we have more cred going to bar than to foo, so bar should definitely have more weight. Expect const bar score equals pg.node of bar.score and foo score foo, and expect bar score dot to be greater than foo score. And we no longer even need the root node here. And this, again, we need to have, oops, QQ, ys to, why is that? Okay. Oh. There we go. Okay. Oh, that's right. Okay. Did that with low convergence and high max iterations. Expected it to be close, the convergence delta to be close to 0. And it wasn't. That's weird. That's okay. That's really weird, right? Because we set a really low convergence threshold, and we let it give 1,000 iterations, and hmm.
I got a bounce dandelion.
Cool. It's been nice having you.
Yeah. Let me know if there's a recording, and I'm trying to think of ways to make this consumable.
Mm-hmm.
If just timestamps or rough outlines of what we went over. So if you have any ideas, just let me know on Discord or whatever.
Cool. Yeah, there totally is a recording. I will upload it to YouTube and send it to you.
Okay, perfect.
Also, if you want to schedule some time to go in depth on the stuff you're working on, and like, the node cards for the Edge node counts.
Yeah.
If you want to schedule an hour and just like pair program on that, I'm happy to do that.
That would be great. Okay.
Yeah.
I'll let you know.
Cool.
For sure.
Yeah, we can just chat about it on Discord.
Sure. Actually, there's an interesting design question. I might start an issue on it. But these projects, when we list them in different places, they should have like a title, right?
When you say these projects, what do you mean?
Like whether it's a repo or a group of repos or whatever data class that we're using.
Yeah, totally should have a
They
title.
should have like a unified way to list their title instead of doing like repo name or however we're doing it right now. So
Totally agree.
that might be an interesting higher level thing to do.
Cool. Yeah, let's chat about it.
Yeah. Alrighty, I'll see you.
Cool. See you, Brian. Okay. I am not even sure if anyone else is on the stream right now, but I'm going to just finish up here and at least get this method tested and commit it, and then I'll probably peace out as well, because it has been, wow, almost 3 hours. Okay, but what is going on here? Why is this convergence threshold not doing what I expected to? I expect the convergence delta to be less than the threshold. Did it not converge? Oh, maybe it just didn't converge, but after 1,000 iterations, really? Could you send your YouTube channel link? Oh yeah, let me take a look at that. Okay, I just put it in the chat. Let me know if that works for you. It's also just in general over here at SourceCred/mission. Okay, so it should finish in less than 1,000 iterations, and then it should... Okay. No, so it didn't converge. This graph just didn't converge. Oh, it must have some weird cyclic behavior. It must be that it like oscillates back and forth, and that's why it's not converging. I think that must be it. This is quite surprising, because it's such a simple graph too. It's such a simple graph. It should just be having foo to root, root to foo, bar to root, root to bar. Yeah, you know what? I can see how this graph would get some sort of weird like cyclic behavior where the cred just kind of like oscillates back and forth maybe. It's pretty ugly though when you think about it. So cred goes from root to bar into foo, and then from bar back to root. What if I just make this 1.1? Will it converge if it's like smaller? That shouldn't matter. I feel like it should just do the same thing. Yeah. Does it change if I give it more iterations? What if I give it 10,000 iterations? Oh, well, that's certainly going to fail, but... Okay. That's really interesting, that it just doesn't converge. Okay, I'm just going to write myself a note here and say, this doesn't converge. Why? And I'm tired, so I'm going to just close it out there. But I'll commit my work, of course. Have some work on converging the graph, or let's call that Juju. Figure out why this little toy graph doesn't converge. It's probably not a bug in our PageRank logic. It's probably just that I'm confused on how PageRank works in this tiny toy example. Speculate that the graph is oscillating rather than converging because so few edges. Okay, cool. Well, made a lot of progress on the PageRank graph. People asked some great questions. Thank you, Jay Louise, for staying here through the end of the stream. This whole thing will get posted on YouTube, like I said, and maybe Brian will even like annotate it with some notes and just like signposting the different parts. Earlier, we had some cool like demo on how to do performance analysis in JavaScript, other stuff like that. And with that, I'm going to close out the stream. Thank you for watching.